All right, everybody, I'm seeing that it's 1:30 on the nose right now, so I would like to welcome all of you to the wonderfully named session, So You Want to Engage in Digital Preservation? And I'm going to add do ya to that. First thing I want to do is, on behalf of the program committee here, I want to remind you to please visit the Ideas Challenge site one more time and find something to join and find yourself a sticker as a participant. There are, I think, 100 ideas there. I went through them earlier today. There's some excellent ideas, and I'm going to join one myself, and I hope more of you do too as well. And I think that goes through the end of the day tomorrow, correct? Yeah, through the end of the day, Thursday. So with that said, I am going to get out of the way and let our wonderful speakers begin. The first talk that we have today, oh no, my phone did a thing, is called Preservation Services for the Broader Community, Andrew Diamond and Bradley Daigle.
Can you guys hear me? Okay, we're going to talk about a new software tool we created called DART, the Digital Archivist Routing Tool, or Digital Artifact Routing Tool, or whatever A you want to put in there. And then we're going to talk about how we are using this tool to allow other organizations to use AP Trust's preservation services. So first of all, what is DART? It is a drag and drop tool for bagging and uploading digital materials. AP Trust provides preservation services for a consortium of 16 universities. We store files in the cloud on S3 on the East Coast and Glacier on the West Coast. And in order to deposit to AP Trust, you have to bag materials in Baggett format. We have a specification spelled out online, and then upload those materials to an S3 bucket, and from there our ingest services will pick them up and ingest them. What we found in working with the larger R1 institutions that are our primary depositors was that we had very few deposits in the first year. And part of the reason for that was that these institutions took a long time to build workflows that would create materials in the Baggett format that we needed and then send those materials up to us. After a year or so, when these institutions had their workflows in place, we started getting a lot of deposits. But the fact that large institutions with fairly good resources were having trouble putting together the workflow told us that smaller institutions with very few technical resources were really going to have a hard time with this. So we've recently opened up AP Trust to some smaller institutions, and they are giving us materials using this tool, DART, and I'll give you a short demonstration of how it works. You can drag files into this UI, any number of files and folders that you want. Choose a packaging format, and at the moment, DART supports Baggett, and we have a built-in AP Trust Baggett profile and a built-in Deepin Baggett profile. You can add your own profiles to this so that DART can produce bags that conform to any profile. So in the packaging step, I chose the AP Trust Baggett format, and I'll skip giving this bag a name. The UI reads the Baggett profile, and it knows which fields in that profile are mandatory, and if certain fields allow only specific values, it understands that as well, and it will validate those values before it lets you go on. It fills in most of the tags by default. So if you look at what's in Baggett.txt, that's filled in for you. Same thing for baginfo.txt. And defaults are settings that you set ahead of time. It just saves you having to do these, set these values on every bag. So AP Trust requires a title, an access level, and a description. So if I fill in just the required tags, then I go to the storage step. At the moment, we support any S3 backend storage layer. In the future, we'll add some additional protocols like FTP, SFTP, and others. I review the job, and then when I run it, it bags the file, validates the file, and then uploads it to the S3 receiving bucket where AP Trust will pick it up and ingest it. If I go to this dashboard, it has a list of recent jobs, and the dashboard actually connects behind the scenes to the AP Trust repository and tells you the status of the bags that you've created and uploaded. So I'm going to go back to these slides, and I'm going to skip through a few of them because I showed you in the demo. Part of the reason for the slides was in case the demo didn't work. So we looked at selecting files and packaging. And I mentioned that Dart currently supports Baget as a packaging format, and it supports multiple Baget profiles. But in the future, we intend to support other formats as well, like tar or RAR or zip or parchive, however you call it. You add your metadata as you construct a bag, and as I mentioned, Dart understands what metadata needs to be there, and it knows how to fill in defaults based on the profiles. Choose where to send this, where to send your bag, and Bradley will talk a little bit later about a DPLA integration that should be coming for this as well. And then you verify what you just are about to run and run it as we saw. Dart, I mentioned that dashboard connects to the AP Trust REST API. Dart is set up to support plugins so that if you want to use this in your own institution or to upload materials to a different repository, you can write a plugin as long as that remote repository has some REST API. You can write a plugin that will connect to that and pull data back into this dashboard, which is a little crude at the moment, but this is kind of alpha, beta level software. So it's open source and cross-platform. We'll give you the GitHub URL for the source repo at the end. It's built on Electron, which is basically an embedded Chrome browser that runs as a standalone application and includes features that normal browsers don't include, like full access to the file system. It runs on Windows, Mac, and Linux. We have a one-click installer at the moment for Windows and Mac. We haven't got to Linux yet. And the application has no external dependencies. So you don't need to download different libraries and keep them up to date or require a specific version of the JVM or anything like that. There's a UI in Dart that allows you to define your own Baget profiles, and it lets you define some fairly sophisticated profiles. I didn't walk through that because that UI is a little more involved, but if you want to look into the product a little more after this talk, you can play with that. It allows you to define your own upload endpoints, whether that's S3 or in the future FTP or some other protocol. And it allows you to define some application level settings like default values for bags If you are bagging at a single institution, your institution metadata, name and address and whatnot are going to be the same in every bag. So just fill those in once, and Dart will take care of them for you. We also store local copies of the manifests of everything you bag in this application, so you can go back and look through those to see if you actually have uploaded something. The plugins will support new packaging formats, new upload protocols, new repository integrations, and setup packages. So a setup package is if you want to use Dart locally at your own organization, and we have a use case like this already at UVA, you may have a use case where you have researchers on one side of campus who need to push data to the library at the other side of campus, and where the library is going to move that data into Dataverse or some other accessible area. You can write a setup package that automatically will configure Dart for your user the first time they run it, and that saves them having to type in a million settings to get up and running. So there's a lot of focus on ease of use in this application. Yeah, the setup plugins include presets that your developer can program in, and then a walkthrough configuration UI, kind of like TurboTax, asking you one simple question at a time. So in the AP Trust setup, I think we set about 20 settings behind the scenes, including like injecting our own custom Bagot profiles into the application. And then the user is responsible for answering like 6 questions, I think. So why did we build it? Bradley will talk a little bit about this, but I wanted to say what I mentioned in the beginning was that actually AP Trust and Deepin both saw little usage in their first year of existence, again, because people didn't have workflows built, and it took them time to build those workflows in the case of AP Trust. They also had issues selecting materials for deposit. They have a limited amount of space that they have to pay for, and so they choose carefully what they want to go into that space. Those were large institutions. We found that smaller institutions that don't have the resources to develop sophisticated workflows and need a tool like this, when we gave it to them, we found that they had pre-identified high-value collections that they had been waiting a year or a couple of years to be able to put somewhere. And so as soon as we gave them this tool, this is Cultural Heritage Organization at UVA, the UVA Law Library, who does not go through our normal UVA library workflows to push things into AP Trust, and Virginia Wesleyan. Those 3 organizations, when we gave them Dart, immediately, as soon as the thing was working correctly, they pushed all this material to us in a couple of weeks, and they had been waiting to push this somewhere. So Bradley's been doing some outreach to smaller organizations around Virginia to try to get them interested in using AP Trust and to describe what services we offer. He can talk a little bit about the work he's been doing in that realm. Bradley? Sure. And then you have a couple slides near that end as well related to DPLA.
Okay. So is this me then for the rest? Okay. So hello, I'm Bradley Daigle. I work with Andrew and Chip German, who's also in the audience, on AP Trust issues. And primarily my focus is content-related issues and strategic partnerships. But a lot of what Dart kind of represents metonymically is workflow challenges that people have. And so I was mentioning this to my friend here in the front row, Mike Jarlow, and he said, but aren't these large organizations, why would they need help bagging? And it's not necessarily that they're inept or that they can't do it, it's just that their mandates and their disposition for how they do workflows might vary in such a way. But what we were seeing across the board was the means by which other organizations should have a tool that's going to work for their workflows regardless of whether we think they should or should not do it. So the work that Andrew's done on Dart is essentially the product of a few conversations and then some observations, as he's mentioned. But then also, it's a prototype of much larger thinking. So as you've already heard, it's open source, it's cross-platform, it's all these elements. And the extensible piece is what's really interesting. So what I'm looking at for Dart's potential across the board is looking at integrating workflows from a more holistic perspective. So in other words, how to work with any size organization to either enhance their access to enterprise level services or to provide a gateway to enterprise level services that they may or may not have. And doing that as easily as possible. One of the examples that we showed, Virginia Wesleyan, it is a small organization, and in many ways it's representative of probably the largest percentage of organizations, which are 1-2 person shops working on a shoestring who have a mandate that isn't necessarily preserve all your stuff because we'll pay for it. And so how do we reach into those nooks and crannies of any state to say, look, we want to bring you into what we're trying to do overall for stewarding the cultural heritage landscape. So Dart's potential is it's modular. And so one of the things that we're looking at is adding some extra functionality. So we want to add packaging formats and network protocols, as Andrew's mentioned, and then make it really much more scriptable on our end. And so this is a work in progress for us. And then Andrew, of course, has a lot of code cleanup, which he always feels that he does. So let me talk a little bit about the DPLA work. So in the conversations, I'm heading up the effort in Virginia and West Virginia to create a combined DPLA hub. And what I've been seeing across the board is these disconnects in workflows that I'm sure you all readily recognize, which is you have selection of digital contents happening here, description might happen here, then we have some kind of digitization or transformation, or it's already born digital, then an access solution, and then possibly, hopefully, some kind of preservation solution. How do we look at creating workflows that provide tools that minimize the amount of training that needs to happen, knowing that where we want to invest the majority of our training resources is going to be largely in the descriptive element, on the metadata creation. So Dart is really an example of how to streamline some of that transport protocols. So for example, this is always my fantasy. I love putting this kind of stuff up here because it doesn't necessarily exist yet, so I can keep adding things all the time. Feel free to start developing some of that and let us know. But my vision for Dart down the road, now that we've got the first prototype in place and it's working extremely well for AP Trust, what I'm thinking of for smaller organizations, any organization, is that you have essentially a modular approach to your content. So for example, my cute little screen here shows that you've identified a collection, you're uploading it, but then you actually can select the various pushes for that content. So for example, if you think about the AP Trust and DPLA mix, you might want to say, here's my collection, I want to select AP Trust and DPLA for this. And then what the Dart tool would do with its extended functionality would say, okay, I get it. That means I need to check your bag against the AP Trust spec, check your bag against the DPLA spec, push the metadata and content to AP Trust, but then only push the metadata to DPLA. And it does all that for the curator, whoever's deciding on these collections. And then you can add other pushes as well. If you say, well, let's send our stuff, we've got a protocol for Internet Archive, we've got a protocol for Meta Archive. Whatever these various ways are that your institution or organization is using, the extension of the Dart tool would allow you to start configuring that. So by doing that, it means that we have the ability to have people focus less on the technology unless they really want to, and more on the appropriate disposition of the materials that they're stewarding. So where to find the code? Here's the GitHub URL and installers. And these slides will be made available so you can find these later. But certainly if you go to GitHub and look for Dart, it should show up. Otherwise, that's kind of the thinking for it. We've got the DPLA folks, the developers are looking already at extending Dart for that functionality, so we're hoping that we'll get some more traction on that. And certainly, since it's open source, we welcome any additional developments on it. So thank you.
Okay, so I have the mic, and we have plenty of time for questions. We finished a bit early. So do I have any questions from the crowd? Way back in the back. Wait for me, I'm coming. I'll try not to run anything over on the way. Don't look at your watch. Sitting there comfortably while I run to you.
Hi. Does Dart have facilities for background uploading? So let's say you want to upload a couple terabytes of data, and you don't want to sit there and twiddle your thumbs while it's doing so. So a la Dropbox, Google Docs, etc., so that you can basically define the bag that you want and say, go do it, and it then goes and takes care of it in the background while you go on doing other things.
Yeah, it does, at the moment, it does upload in the background. I have to make a small change to it because the way it's coded right now, it expects that the UI is still present while it's uploading. Even if the UI is not present, the upload will continue. But yes, it is working in the background right now. I need to make a change to make that a little more robust, but it's a small change. And we have, like one of our use cases, UVA Cultural Heritage, is bagging, like at this point, a few hundred gigs at a time, and they have to run their uploads overnight just because that's just how long it takes. So I don't know quite how to work around that. Some people have laptops and they want to pick up and walk off while the upload's going, and that doesn't work. But
Other questions? Sam.
Just follow on to that, how much of that is just based on their bandwidth internet connection versus anything with the tool itself?
it's very highly based on the bandwidth of their connection.
Yep.
UVA Cultural Heritage has very few problems, and Virginia Wesleyan has more problems with smaller bags. I did want to mention that that UI soon at the moment it allows you to define these ad hoc workflows, which means like bag material in this format with these default values and upload it to this place. It will have workflows so that you can say, I want you to do to this bag the same thing that I did to the other bag, right? And those workflows are actually described in JSON, and at a certain point, we'll make this whole thing scriptable so that you can use the UI to build a workflow and then save that off and then use a command line version of this tool in your Python scripts or your Ruby scripts to say, like, apply this saved workflow right here to everything in that directory right there. Because I think that will be more useful for larger organizations to have a scriptable workflow.
Other questions? We still have a bit of time.
I have a simple question. How does this system connect the repository? For example, sudo.
So the system isn't meant to connect deeply into any repository. It's really meant to deliver materials to some area where the repository can pick it up, or where it can be picked up by some workflow, maybe your library's workflow, that pulls it into a repository. The only connection to an actual repository is through a REST API that queries the repository and asks, what is the status of this item? Has it been ingested yet? If so, how can I access it once it's in there? So there's no deep integration to a repository.
I have a question for you, Bradley, actually. Or did you want to add to
Yep,
that?
go ahead.
My question for you is about the DPLA and Internet Archive suggestions in your little drawing. Do you currently have AP Trust use cases that are driving that sort of development? Do you see yourself doing that for members? And can you describe them briefly?
Sure. So I think Virginia Wesleyan is a good example. It's a small liberal arts college. And doing the DPLA work as we're seeing it right now, we're developing a sub-hub model where there's going to be regional hubs that are aggregating content and then delivering it to, let's say, the DPLA, the metadata DPLA. But we're looking at, so AP Trust is using Dart as a kind of a prototype to instantiate, but then also scale up microservices so that we can't replicate our staff to train everybody on how to get their content ready and delivered to us, but we can create tools that make it easier for other partners to train around for both description and delivery. So as the DPLA hub comes online, we're also looking at consortial models for AP Trust to say, all right, look, part of one of the services for the West Virginia DPLA hub is that we offer preservation services that you can take advantage of if you'd want to. And by the way, these are your regional partners who will train you on how to describe your collections and then use the tool to port it to whatever service that you want to use. So we have several use cases right now, and in addition to that, we've got a few more beta testers who are playing with it with those workflows.
Thank you. We still have a few more minutes for questions. Does anyone else have a last go? Okay, then let's thank them one last time for an excellent presentation. Aviva's going to set up her slides in a second, so just give us one moment to set up. I was going to ask you to sing, Aviva, now that I know you can.
I'm gonna have plenty of time, I promise.
Yeah, we're good. We're still 3 minutes into the first half hour. Can I help?
No, it's fine.
There it is. All right, I have the pleasure to introduce Beyond the Repository by our wonderful co-chair, Aviva Weinraub.
Hi, I'm going to talk a little bit about an IMLS grant, the research that was done from the IMLS grant that we had on integrating local preservation systems with national distribution services. You'll have to forgive me if you ask me very specific questions about the data at the end. I'm not going to have very good answers for you since I haven't really read the report in detail since January, so I apologize in advance, but I've had some other things like open repositories. So here we go. Sybil Schaefer and I came up with the idea for this grant after I had worked with her on the Digital Preservation Network. And we really had 3 high-level goals in mind when we were building this project. Really to investigate common problems in digital object curation, versioning, and interoperability between local repositories and distributed preservation systems, to identify broadly applicable use cases and design patterns, and then to propose some high-level technical solutions. So this was a really highly collaborative project. We had a number of team members from Northwestern and Sybil Schaefer, who is, I did not say, she is at UC San Diego on the Chronopolis project. We also had an advisory board composed of representatives from a number of organizations in the distributed digital preservation field who offered advice and guidance during the research process, including Mike Giarlo, who's sitting in the front row. Sorry, just because, anyway, okay. All right, so we came up with 3 main research questions. So how does one curate objects into a long-term dark preservation system? So that is, how do digital preservation practitioners prioritize a subset of their content to be ingested into a distributed digital preservation system. How does versioning play out in a long-term dark preservation system? If long-term dark systems are designed to be just that, long-term and dark, how does versioning actually occur? And can versioning be automated in systems like this? And finally, how can systems interoperate more effectively so that digital preservation is both better and easier? So to answer these questions, we used a two-part methodology. First, we conducted a survey of digital preservation practitioners. So if you were one of our 170 respondents, thank you. The goals of this survey were to understand local systems and to get a broad picture of what people are currently doing and what their pain points are. Next, we held a series of in-depth interviews with some of the survey respondents to dig deeper into their digital preservation environments. Using the information gathered from the survey and the interviews, we worked with the advisory board to make high-level recommendations to increase interoperability between those systems. So we disseminated the results that we had in December of last year. So the survey results. We had 170 valid responses. 65% of the institutions that responded had collected 10 terabytes or more of data. More than 80% expected that their content would grow by at least 10 terabytes in the coming year. There's wide geographic distribution represented, including 15 international responses, which was something that we were not necessarily expecting. We had responses primarily, about 77%, from academic libraries, and we had 73 people who were willing to discuss this further with us, which we thought was actually really great. And we were, if I'm being honest with you, we were hoping for about 40 institutions to respond. That was our, 35 to 40 was our goal. So 170 really just blew us away. So you'll notice in this graph, this is the systems that are primarily used locally. DSpace is obviously the biggest user out there, with homegrown systems, and then Fedora following close behind there. And obviously Hydra is now Samvera. So as far as distributed storage and the number of copies that each institution was keeping, 85% of respondents reported that they were keeping multiple copies in multiple locations. But of these, the vast majority were keeping those 3 copies in some sort of local environment. And funding was cited as the most common barrier for not keeping multiple copies. And you'll notice there's actually a pretty big jump at around 7, and those were primarily institutions that were using some sort of lock-space network. So where copies were stored, we had, again, multiple locations on site. So you had one locally, one maybe kept at another data center on your campus, and then probably one copy kept in some sort of Iron Mountain-like facility. With the cloud being way, way, way far behind on that. Again, this data is over a year old. Those numbers might be a little bit different if we were to approach people about this now. We had a relatively large number of institutions that were using a DDP service like AP Trust or Chronopolis. And some people were actually keeping their data at partner institutions. A lot of institutions were also using Internet Archive, which I thought was an interesting thing. That was sort of a surprising answer for a lot of us. So in terms of how copies were tracked, automated tools, 30 respondents of them were saying that they used logs, backup reports, and some sort of third-party service. But the overwhelming number of institutions beside that were using some sort of spreadsheet or homegrown database or some other manual method to keep track of information. So when versioning distributed copies, 85% of those were reporting keeping all versions of everything that they had versioned, which was a lot of copies. 20% reported only keeping the newest version. 20% were not really sure what they were doing. And many indicated that versioning practices are dependent on the material type. So AV materials might be treated differently than images. In terms of curation, 48% of our respondents said that they selected a subset of materials to go into the repository, And the top two selected criterias were mandated, so if you were some sort of a state repository that you needed to be keeping this information for some reason, or of sort of unique and intrinsic value in and of itself. So we did these interviews as the second phase of the survey. We interviewed 12 institutions. So we really tried to get, you'll remember I said 77% of the respondents were from academic libraries, but we really wanted to get a nice broad view of what was available. So we reached out to 6 public universities, 2 private universities, 2 museums, 1 public library, and 1 government archive. And that we thought would give us a nice distribution of data from various groups that are doing this type of work. So the interviewees collectively use 8 different local repository systems, which was again something that we were looking for. We really wanted some diversity in what we were getting in terms of feedback, and 4 different DDP systems. So in terms of the interviews, we got some really interesting quotes, which I'm gonna try and read some of the pieces of to you. So one of them was, well, if the risk involved in losing that content would mean losing that information entirely, then I want that to be preserved in meta-archive. Otherwise, I don't really care. And then a lot of people were saying, born digital, super fragile, things on unstable formats, then they'll pay vendors to reformat it, and then they'll do full-fledged digital preservation work. But otherwise, that's not where they're going. In terms of versioning, we had feedback saying things like, I think our versioning has been somewhat haphazard, not terribly deliberate. And other times that I've talked about this, these sorts of answers seem to resonate with a lot of other people. So again, with versioning, what are the real use cases? For special collections, all versions are first-class objects. The first group of TIFFs were a mistake. You don't want to go back and keep them. For digital archives, versioning is moot. For digital collections, it's just too expensive. So in terms of interoperability, a lot of people were saying nothing interacts with anything else, right? Nothing is connected, it's all kept separately. We just have workarounds. Interoperability is the main challenge that we have, whether it's our descriptive systems or our preservation systems, nothing talks to anything. So the brutal honesty, these were, I think, some really good quotes, right? So in terms of any sort of catastrophic event, we're pretty much toast, right? Everything's gone, good luck. One of my favorites is, we've been around since 1849, and this is the first time that the institution has acknowledged that preservation is worthy of a full-time position, right? So we're not necessarily prioritizing this type of work. And it's hard to convince stakeholders that digital preservation is worth something. It's worth money. It's not glamorous. It's just computer stuff. So in terms of our conclusions, how do we curate objects to ingest into these DDP systems? Mandate and intrinsic value were clearly important based on the feedback that we got. There was some consensus that there are different tiers of digital preservation, so that not all material is worthy of preservation at the highest tier, and that the highest tier of preservation is likely your DDP system. So how does versioning of objects and metadata play out in a long-term DDP system, and how do we automate these actions? And there's no consistent versioning practice locally, so why would we expect that there would be one in some sort of distributed system? How can systems that store data differently be made more interoperable? Well, bags at this point are the most common form of data packaging. So where do we work from there? So we came up with 3 basic recommendations. So based on our findings, the conversations that we had with our advisory board, we made these 3 major recommendations. The first is a shared Bagot spec for local repository systems that would promote interoperability between various local tools and DDP providers. The second is a standardized API for distributed digital preservation services, which would allow organizations to more easily track their content. And finally, we propose developing a curation decision toolkit as a way to assist in digital preservation policymaking. So our report detailing our research and recommendations was completed in December and was deposited into Northwestern's institutional repository. The bit.ly is there. It will also be on my final slide. The proposal that we submitted to IMLS really brought together many of the people, so we disseminated it through the usual listservs in early 2018. What we are doing right now, literally today, I pressed send with our OSR office like an hour ago. We submitted the second round IMLS grant for implementation. So we're working with, hopefully, with NDSA to create a curation toolkit that will assist cultural heritage organizations in choosing materials to send to their DDP systems. So we reached out to representatives in the DDP space and will hopefully have funding to create a shared Bagot profile to increase interoperability between repositories and DDP services. We're also hoping for funding for Fedora and DSpace repository systems to implement the shared profile in their Bagot export feature. We've also, hopefully, will be able to work with LOCKSS and AP Trust to update their systems to be able to accept the shared Bagot profile. LOCKSS will extend their metadata database schema to support metadata from the profile, and AP Trust will enhance their API to expose tags from the profile, thereby allowing users to generate reports on content that they submitted to the provider. So all of this is, of course, theoretical, assuming that we actually get the funding, so fingers crossed if any of you were on the committee. And there you go. So I'm happy to answer, as I said, anything that I can. If you'd like more specific data on what we actually, like the data that we actually collected, all of it is in the report. The bit.ly is right there. I can also put you in touch with Sybil Schaefer at UCSD or Laura Alanya at Northwestern, who at this point are really the primary researchers and the project's leads on our next step work and led a lot of the research on this project itself. So I think that was 15 minutes.
So as my friend Justin Simpson at Artifactual says, we have oceans of time for questions. First question from the audience.
Is that good, huh?
It takes me a while to pan too, just FYI.
You guys really want to hear me sing, don't you?
I guess I do have one question for you. The 2 slides ago, or one, there we go, wait. The curation decision tools. Could you describe a little bit about what your idea is, about what kinds of tools you're thinking of?
So I think what we were talking about was really coming up with a sort of way of approaching how you think about what objects would go into a DDP system versus some sort of local preservation network. And a lot of that was really around this idea of, you know, is this something that you need to keep because the federal government or the state government or your university is telling you that you have to, or this is a thing of special and intrinsic value. This object only exists in a born digital space. It is from a researcher of X, Y, and Z importance. That was sort of what we were thinking would come from it. It's what we're asking for from that group is really for them to come up with what they think the curation recommendations are. So we're trying to not go into it with too many preconceived ideas of what we're asking them to come up with.
Hi. I'm wondering about like software dependencies and how those fit into this conversation, or if that's like, keep that over there.
It's kind of, we're keeping it over
Okay,
there
cool.
for now, yeah. For the most part, again, those recommendations that we came up with are trying to separate that out as much as possible. But it's obviously still a thing that we need to be concerned about. Hey, Brad.
So you mentioned the curatorial decision tools and the NDSA. So do you want to talk a little bit more about that?
I don't really have much more to say about it. So we've identified somebody within NDSA to lead that project with Laura, who also works with NDSA, and then they've identified, I think, 3 other people to work on that team with them. So the idea of the grant is it's a 2-year grant, and they will actually have that work done within the first 10 months of the project, and then we'll release the recommendations publicly through various listservs and whatnot. they are meeting, the idea is for them to meet twice. They would be coming to Chicago, Evanston, Northwestern to do that work. I think a lot of it exists. I think a lot of us sort of know what we want, but we haven't actually seen a toolkit out there that actually helps with some of that decision making. So it's really designed to sort of help you create those local workflows.
Okay, so that was a very self-serving leading question on my part as well, because the NDSA is also working on rebooting the levels of preservation.
Yeah.
And one of the components that have been identified is a curatorial overlay to the levels of preservation. So we should talk to bring those two efforts more closely aligned.
Agreed. I hope that they were already thinking about it ahead of time, but we'll talk.
Okay.
Yeah. And it's not like we're not working ostensibly, hopefully, together on this moving forward anyway. Yeah. There's a question in the back.
Hey, Dan, coming to you as quick as I can.
We have time. You don't need to rush.
That's true. Oceans of time.
Just wondering if some of the community-driven open standards like PCDM or OCFL came up during this, either in the report writing phase or in the responses that you were getting looking at interoperability.
I'm going to let Giarlo answer that question.
Wait, Giarlo, let me bring you a mic.
I mean, yes, they came up, but yeah, I mean, I don't know that. Yes, they came up, but
this is awkward because my answer is going to be no.
I mean, they did a little bit. You think they were no?
My memory doesn't extend back that far.
We talked about it for like an hour and a half in San Diego.
There you go.
Long day.
Over possibly liquid beverages?
No, there were no, well, there was iced tea.
Other questions?
So as I said, the report is there. You should definitely take a look at it. It's really interesting. I thought anyway, but I like graphs and charts. So, as I said, we'll keep you posted if we actually get second round funding. So thanks.
Thank you so much, Aviva. Yes, you can talk as slowly as you'd like. So next up, we have Saskia Van Bergen talking about a roadmap for the management of 3 million digital objects in a repository.
I hope you don't expect me to fill up the other 45 minutes.
Well, I mean, there are 3 million objects, so you're going to go through all of them, right?
I'll do my best. Let me see where it is. Is it going already? Oh, yep. There it is. Okay. Hi, I'm Saskia van Bergen. I work as a project manager and a process manager for the Department Innovation and Projects of Leiden University Libraries. And my projects and my activities mainly concern digital special collections or digital heritage, if you want to call it like that. Facilitating the availability and use of digital special collections form important tasks of our library. We digitize our own paper heritage, both in-house and externally, and we participate in various digitization programs. And the digital heritage collections could be found in different systems using a variety of ways to present and to store them. This was not very practical for our users, of course, and it was also a lot of work for us to maintain it, and also very expensive. And for this reason, our library started a project to redesign our infrastructure about 5 years ago. And we have built our own based on Islandora. And at the moment, our repository contains about 1.5 million objects, about 40 terabytes. And we have nearly finished the migration of our digital heritage collections from the old infrastructures to Islandora. But we have also digitized quite a lot of collections that haven't been ingested yet because of our migration project. And we have also already started new projects resulting in digital collections as well. And besides that, in next year, 2019, we plan to migrate our scholarly repository containing the publications of Leiden University to the Islandora environment as well. So in the course of 2019, our complete digital collection is thus expected to grow up to 3 million objects and about 60 terabytes, I guess. I'm not completely sure. So Islandora is OIS compliant, but this is of course not a standard for quality of service. It's just a reference model that operates at a conceptual level. And this presentation focuses on the roadmap for improving the visibility, usability, and sustainability of our digital heritage collection, and not focusing on the technical parts like checksums and fixity check, that kind of stuff, but more on the workflows and on the policies. So all the other things that are important to guarantee future reuse of the use and reuse of the collection. And I will focus on the heritage part because that's what I'm doing. But of course, it's also applicable to research data and the publications as well. So the entire chain from selection and acquisition to availability and use of our digital collection is very complex, and it involves a large number of departments and persons. And at our library, the responsibilities for the individual steps in the process are generally well allocated. That means that the Center of Digital Scholarship identifies needs in the field of digitization and also the use by digital collections by our researchers. Our digitization is, as I said, done in-house or outsourced. And the curators are responsible for selection and for description and availability. And of course, everything with respect to copyright restrictions. And the workflows relating to copyrights, such as agreements with rights holders, the clearing of rights, are the responsibilities of our Special Collections Department. And our metadata department advises on metadata standards and supports batch operations. And our digital services manages the infrastructure. And last but not least, the project manager for the special collections, which is me, coordinates large-scale digitization projects. And I am also a consultant in the field of digital sustainability, standards, innovations, and this often leads to policy advice. The problem is that decisions regarding policy and implementation are ideally based on a full consideration of the entire chain. And in Leiden, it was unclear who bore the overall responsibility for the digital collections. There were regular meetings between the departments involved, but it was not on a structural basis. And the meetings were usually limited to just a number of departments in the chain. So we really felt the need for a dedicated manager of the digital collection as a whole. And we called it a process coordinator. And this role, at least for the moment, has been given to me as well, which is kind of risky, I have to admit, because normally it's not very healthy to be a project manager and then become responsible for the collection as well. It's not the normal thing to do, so we will have to see after this project has ended if it works out fine. I already have the idea that it's not something I can do on my own, so I was really happy to see on the slide of Eviva that it is actually a real job. It's not something that you can do a couple of hours a week besides your normal tasks. So some of the tasks that I've received is that I have a leading role in setting up work processes around digital heritage, such as the digitization projects, development of the digitization workflow, the infrastructure, and the online presentation. So I monitor the work processes, you could say. And I also draw up agreements, procedures, regulations, etc. And I also try to ensure that they are complied with. I'm also responsible for the communication of agreements and the administration of the digital collections and drawing up policy notes for the board. So it's quite a lot. So my first task as a process manager was to create a roadmap for the management of our digital collections. And actually this helped me to get a more concrete picture of the goals. And each year agreements are made with regard to the process. And in the first place, for each task, a set of essential tools and documents was defined, consisting, for example, of policy documents, process descriptions, templates, checklists, spreadsheets, calculations and descriptions of digitization projects. And the interesting thing was that it turned out that several colleagues in the library had already been working on these documents and tools, but they were never stored in one place, and the status was not very clear, and there was a lot of duplication in it. So next step was to analyze the status of each of these tools and defining if the first steps yet have to be taken, the work is in progress, but it's still ongoing, or it already has a definite form, it is in production and only has to be updated periodically. And on the slide, you see some examples of this. There is I've given them various sub-headings, like a framework consisting of a policy regarding open access and an overview of the preferred formats. There is one block named process, and it contains, for example, the SharePoint for copyright clearing that we've created. There are key figures, like, for example, an overview of the costs of digitization. So if we are trying to get funding for a digitization project, and a curator comes to me and asks, okay, what amount of money should I reserve for the digitization and also for the storage and making it accessible? Do you have some kind of parameters that I can use? So we created these. And there was also a part named consultancy or best practice with some frequently asked questions on the websites for researchers, for example. So then how do I know that I'm doing the right thing? How do I measure the quality regarding to the management of the digital collection? Well, and at that point, certification came inside. Well, in the world, and specifically in the Netherlands, there are more and more organizations that store large quantities of digital material in a sustainable manner. For example, our National Archive, Institute of Sound and Image, they all have large digital repositories. And everyone assumes that these institutions work professionally, of course, and that digital collections are stored safely. But nevertheless, this trust will be periodically, has to be clearly demonstrated to external parties through audit and through certification. And here on this map, you see the several certifications that are around in the world. And in the Netherlands, we have been quite active in that field. There are 8, 10, 12, 14 at this moment. But this map is not up to date because I understood from some of my colleagues that there are already more certificated repositories now, but they are still not on the map. So, and they're not just research data repositories, although there's a strong focus on it, but there are also repositories dealing with digital heritage collections. and they can have a core trust seal certification, a Nestor, or an ISO. So there are several. Yeah, so recent developments in digital trustworthiness have led to the development of criteria and certifications that can be used as tools. And the core trust seal is one of them. It was developed in the first place as the data sale of approval by the Dutch organization DANS in an effort to develop a basic certification distilled from other services that were already around. And it's formulated in 16 guidelines for the application and verification of quality aspects with regard to the creation, storage, and the use of data. They formulated it specifically for research data. And if you want to get a certificated repository, you must follow two stages to obtain it. The first is to perform a self-assessment against the requirements, and afterwards there is a peer review, a member of the CTS group, and they will provide feedback, and the organization applying for the certification can then modify and improve the assessment and submit for a final round of review. It looks like a very bureaucratic thing to do, but actually I found out that the requirements are for the most part very practical and very down to earth and very useful. And this is an overview of the requirements, but it's not really necessary to look at them in detail, I think. They deal with organizational infrastructure and only a small part of technology, as you can see here. So, and the developers, they list a lot of benefits for acquiring the core trust seal, like trustworthiness, improvements in process, transparency, you can differentiate from others. But at the same time, we also know that it can be very labor intensive, time consuming, and sometimes even expensive. And it can be quite difficult to achieve if it is underestimated. And the problem at our institution was that our management considered it as a bureaucratic burden, and they were not immediately enthusiastic about it. So they not immediately said, oh yeah, let's do it. We want to have it. And I thought, how can I make clear that these very down-to-earth practical requirements actually can help us and help our organization to improve the management of our digital collections. And at the same time, an intern came to our library and she said, well, a student, and she asked if she could do an internship. And I thought, well, maybe it's a good idea if she performs a preliminary investigation for the certification of our repository. So I made her examine the benefits and the risks of acquiring the CTS in relation to the Islandora repository that we're having. And her research consisted of 3 parts. So she first did an analysis of the requirements. How far are we already? Are each of the requirements we are completely lacking? We have made no steps yet to meet the requirements, or we are quite okay. We just need some updates, or yeah, we are fine. We're done or almost done. And she also interviewed Dutch repository managers who already have a certification, and she asked them what were the reasons for the certification process, how they prepared for it, what difficulties they encountered, what benefits they experienced from the process, and also the time management, the time investment. How much time did it cost to get it? And the last point which is even more important, she did a business case analysis and try to figure out, yes, for each stakeholder, yes, we really need to be a certificated repository, and yes, we need it right now, or we can wait for a couple of years and then we will see, or is it really that necessary? Maybe we can be very trustful or trustworthy without having a certification. That's what we wanted to find out. A bit more about the business case analysis. So she made it of all our internal and external stakeholders, all of them who can affect and be affected by the certification, and each of them is different in terms of importance, influence, and needs. And for example, a very important one to me, the influence of Dutch funding agencies is potentially high. Certification signifies to funders that the data they have, the money they have invested, will continue in data that will be available for reuse in the future. And without certification, we risk to miss this opportunity of financial support. And it's not a requirement for funding yet, but it is expected to be in the near future. And that is what everyone we spoke to made clear to us, that not enough Dutch repositories do have a certification at the moment, so they can't really require it, but they expect that the higher the level gets, that it will be some kind of obligation. So then you really have to. So you better be prepared, because it's waiting for us. And this is important for us because a lot of our digitization projects for our heritage are funded by external partners, like the government. So we don't want to miss out on that. Her conclusion was, our conclusion maybe, was that yes, it makes a lot of sense and it is very useful to have a certification on your repository, but there's still a lot to be done before it is within reach. Although it is tempting to simply start a certification project, so we always have these ideas of we just plan it for next year and we will start a certification project and then we'll just do it in 1 year. And we realized, well, that won't work. A much better idea is to focus on the self-assessment and the self-improvement in the first place. So really the improvement of our internal processes. And actually the migration project that I'm doing right now is very useful in that respect, because this gives me a lot of information about the collection and the administration of it. So all the things that weren't clear to me when the data were in the other repository, and now we are working with it, and I get a lot of data that I can administrate for myself about the collections. And third important thing was that make a list of activities with a schedule, deliverables, and objectives, make it very smart. So that gives you the biggest chance that really someone is going to work on it. And make sure that, for example, it gets into the year plans of your department or of your university library. And last thing, focus first on the development of a well-formulated preservation plan. General and specific needs for the care of collections are determined, priorities are established, and resources for implementations are identified in it. And what we realized is that the first three bullets of advice were already started with the roadmap that we talked about in the first place. But the last bullet was completely new to us, and it's actually a very important recommendation. It is at the heart of the whole of your activities. and also the heart of the whole audit process. And it offers context to the activities identified in the roadmap. This actually gave me the possibility to make also clear to our management team and to convince them what actions are needed. And that, yeah, okay, certification is nice, but first you have to be well organized. You have to be prepared. And that it was completely clear that we weren't prepared yet. And that was something very useful that our intern made clear with her report. Then it was written down, and not by myself, but by someone else, although it was an intern, that didn't really matter. And yeah, it really helped us to make a step forward. And yep, okay. So for the last couple of years, various data repositories in the world have successfully applied for a certification seal. And most seal holders refer to the external benefits in the form of increased awareness of the value of their repositories to their communities and funders. But the experience in our library is that the internal benefits must not be underestimated either. By focusing on these, we were able to convince management that actions were actually needed. And for our library, it started with the need to improve the management and of an expanded repository and the improvement of our internal processes. So to be able to create these 3 million objects in a professional way, administration, documentation is essential, and creating the role of this process manager and drawing up a roadmap functioned for us as a catalyst for change. So at present, we really have a clear idea of the requirements, and this helps us to draw up a work plan. And more importantly, starting with a self-assessment, we will also achieve a greater sense of involvement, as everyone will have become more aware of his or her role and responsibility in the whole process. And so we really consider it as a shared responsibility. And within this process, certification is not perceived as a goal in itself, but I think it will simply be the result of all the activities that we will perform this and next year. Thank you.
All right, questions? Yes, 1 sec.
Yes, you were talking about initial skepticism from management. What arguments did they find most persuasive?
They said, well, it's not really necessary. They really consider that something bureaucratic. And they also said that the goal of our digital collection was giving access and not preservation on a long term, because we have other institutions like the National Library who are already doing it. Must sound familiar. What was interesting to notice is that I really underestimated how well it worked to have an intern, because she spends the whole week on nothing else but that, and I would never have had time to do the same things. And we also agreed that every month we would meet with management and the intern and me to talk about the process. And that really helped as well, because every month they saw the issues coming up, the requirements that we didn't meet yet. And as I told, I could have told them, but it wouldn't have worked the same way, I guess. Just writing it down by someone else, it helps.
Back here.
Hi, I might have missed the first bit, but if they said those 3 million items weren't for long-term preservation, what would be the point of even, I just got a bit distracted by that. So what would they think would happen to these items or artifacts or whatever they were?
Yeah, you're absolutely right. They just had the idea that it wasn't the mission of our library, and we do digitize in a national program as well, and these scans are put in a national repository, and they said that, well, everything that has to be kept for the long term will be in there. That's it.
I have a question for you before I take another from the audience. So this is about the Core Trust seal itself, and forgive me, I am aware of it, but I haven't actually dug too deep into it. Does the Core Trust seal provide a template for gathering of evidence, or is that largely up to the institution to decide how they want to gather the evidence for all of the requirements?
I don't think that they have a template, but they ask you to provide evidence how you meet with the requirements, and ideally you publish them online. Only if you have very good reasons to keep them private, you can do without. But the best way to do is to publish them online so that also the reviewer can access them.
And you mentioned a 3-step process with the Core Trust seal, wherein you do an internal audit, then you move to peer-to-peer, and
Exactly,
then the
yeah.
external certification. Is that just the choice that you made as an institution, or is that a requirement of
No,
Core Trust?
that's how the process goes. And what they do, well, when you read these requirements, you will notice that they are for research data, and for every institution you have to translate them and make them relevant for your institution. So they may sound quite abstract when you read them first time, but yeah, as I told, they're actually very practical and down to earth. And what this peer reviewer does is he or she looks if you meet the requirements, but this is a more or less subjective, you could say, because you have to renew it every 2 years. And so they might say, it's okay for now, it's not perfect, but it's okay for now, and in 2 years we will see again, and then you have to show that you've made some improvements on that part. So, yeah.
Sorry, last question about this.
Yeah.
After the 2-year period, then do you have to go through each stage again, or is it just the external reviewer every 2 years?
Yeah, so after 2 years you have to renew it, and then they will do the check once again, and you have to improve the points that they commented on the 2 years before. Yeah, so you have to add extra information, for example.
Thank you. Other questions from the audience? Going. All right, we have a little bit of time left. Let's thank all the speakers this afternoon one more time. Thanks, everybody. Walking out the door, you have extra time to look at the Ideas Challenge and join a challenge. Find a team.
Please do. I mean,
Straight up knocked him out. Like the first time, he was like, you know, we were doing kicks, and I kicked him, and his like thing was here, and I kicked it up high enough that the top of my foot and the entire like mat that I was in hit the bottom of his chin, and I like lifted him up, I lifted him up out of the air, and like I could see him like basically going this. But it was amazing. Like I mean, he was obviously enough of a master that he was able to sort of handle it. Next time I got him in the board, that was nice. I'm really sorry. I did everything wrong. Oh. You know you want to go. Is it actually good? Is it actually good or so bad it's good? I think that's good. It gets the patch. Courtney's volunteered for the NDSA team, so well, actually, did you know that the person who's leading it is actually yeah. Well, I mean, so it's connected to Lauren. I assume she was. But I think the idea of the level of perspective, once somebody goes there and somebody else or someone's going to do it. So if you're going on the form of the idea, that's interesting. I would believe yeah, but you can look at that. Well, you can also do that. That may have been the code of conduct. Yeah. Actually, yesterday we were in Berkeley. Yeah. And the driver was like way like code of conduct and bad. Oh yeah. And we all got out of the car.
This is annoying. No, I don't know where.
You're putting your slides up there.
So you should put your threads too, but I don't know Windows very well.
Oh, okay. Do you want some help?
And so, for example, I cannot find where to take these out.
Oh,
and then
you can just pull it out. But is your slide on the?
It is
desktop?
here,
Yeah.
yes.
Okay.
And then look, you may not want to do it, but I don't know how this with my.
Yep. So so when you start the slide, it should show up. So just click on that icon down there. See the little slideshow looking icon.
These?
Yep.
Oh,
Okay,
I see.
and then you get your speaker notes as well, or you should get your
I
speaker
don't have
notes.
notes. So, okay, so that's all I need to do. I guess I just can. Okay, and then we open it up whenever. Yeah, and I have here two websites
Browsers,
open, but I need.
Yep. Okay. So do you want your USB keyboard?
I'm sorry.
So you can just pull it out.
Okay.
I've never seen a computer pull it. Loading out? Yep, loading it. Speaker notes. I love it on that. Just some animations on it. Excellent. It was the last thing. I was like, okay, that's it. Yeah, it's HDMI. Woo! But anyway, okay, so this is just leading up to the site. So it comes back, and I'm sitting together with the middle. What did you put? So it's a bullshit. He said that quote unquote. And I'm like, I know that. What were you thinking? So then, I'm hoping it gets repackaged with a price. So what do you think they put? I'm gonna rebound. Don't worry, everybody, this is just a test. You think that would stop the speaker?
Depends on the speaker.
Yeah.
I was gonna say.
I've been doing stuff to try and get the laser. Yeah. This is, I'm guessing this is.
And then, yeah, of course. Just think you just pull it to the other side. Is that what it is? Okay. Sorry. Do you have to run the mic in this room too? I was thinking one thing that would have helped when I ran the mic yesterday is if this crews just come with me. Because I don't have to hear what setting for that. We don't have to hear that. So it's like the speaker runs the mic. Oh, and just then they, and then they take it back and talk.
Let me make this bigger. Yeah.
All right, we're going to go ahead and get started. The last session of the second day. This session is taking data to the next level. I'm Holly Mercer. I'm at the University of Tennessee, and I will be chairing the session. Our first group of speakers, they're all from Montana State. Sarah Mannheimer, Jason Clark, and James Espeland are going to present on a prototype for the Institutional Research Data Index. And I'll probably from down below introduce the other speakers and try to keep things moving along so everyone has as much time as they need. That better? All right. Well, I'm going to be down there for the rest of the time, but now the speakers are all set. Thanks.
Okay. Yeah, so as Holly said, we'll talk about the Institutional Research Data Index, which is a prototype, a very early prototype we've built recently. Can you hear me okay? How's that? I'm Sarah Mannheimer. I'm the data librarian here. And Jason Clark is the head of special collections and archival informatics. Jim Esplin is a software engineer in the library. So we'll talk about the institutional data repository problem as we see it, then our proposed solution. Then Jason will talk through the metadata model for the prototype, and Jim will do a little demo. And then lastly, we'll talk about some challenges that we hope we can get feedback from the OR community about. So first, the problem. Out-of-the-box IR systems aren't designed for research data. So we started by putting research data sets into our DSpace repository, but it became clear that it just wasn't a great fit. IRs are designed for articles, which are published once in a final state, but data is often published in a preliminary state and then updated to new versions as projects progress. IRs also don't have data-specific features like file-level description or DOIs for each file and data-specific metadata. And if you want to customize these systems to fit data, it can prevent upgrading to new versions since you have to re-customize each time you upgrade. A good example of how this problem is Dryad, which is built with version 1 of DSpace, and they've customized it so much that they're still on version 1. But you may have seen that Dryad's connecting with California Digital Library, and they're going to build a new platform, they say. But in any case, the second problem is that data-specific repository systems can be resource intensive. So when we were thinking about how data didn't quite fit into our DSpace repository, we went through a process of evaluating other systems, data-specific repository systems, to see if they could work for us. But we found, obviously, that open source systems require developer hours and data storage infrastructure, and vendor solutions require subscription payment. And these resources that we would expend to build the data-specific repository are in addition to those required for our existing IR. So in a small or mid-sized institution like MSU, it just seemed a little out of our reach. And there are currently 1,000 data repositories in the United States and more than 2,000 worldwide. This is from RE3 data. So, and many of those repositories have the services and policies that ensure their trustworthiness and suitability for institutional research data. So we thought to ourselves, well, okay, let me talk about this little study that I did with some colleagues here at the university. We looked at what drives discovery and reuse of open data sets. It was a small, very exploratory study, but the results seem to indicate that data is more likely to be discovered and reused if they're archived in a discipline-specific repository and if they're indexed in multiple places online. So using that information, we thought to ourselves, why don't we build an index so we can direct researchers to deposit their data in these third-party repositories that are out there, 1,000 in the US, and then we'll provide an index that gives local access to our institutional research data. And so we are doing that. ERDI is a metadata index that promotes discovery and reuse of institutional research data sets while expending fewer resources than those required for an institutional data repository. And we call it ERDI. It's sort of hard to say, but we'll be saying that throughout the rest of the presentation. So the idea is that unlike a data repository, ERDI doesn't archive and store data sets. Instead, it harvests metadata from those third-party repositories, and then it serves the metadata via an online interface. It's sort of like a book catalog. You know, the catalog doesn't have the actual books in it, but it directs our patrons to know where to find the books. So here it's like a signpost directing our users to data that may exist in Dryad or ICPSR. So we had a few inspirations. There's some projects that are already doing this kind of work. DataMed, which is funded by NIH, the BioCaddy project. And then NYU Health Sciences Library has a data catalog that provides access mostly to data sets that aren't ready to be published publicly. Then Synergy, Omics DI, and Share are 3 other projects. But the innovations that we're focusing on is we have this institutional focus. So we're looking at just data sets from MSU. And then we're also going to try to automatically generate some new descriptive metadata for individual data sets using topic mining of scholarly profile sources like ORCID and Google Scholar. And Jason will talk more about that. And then lastly, we will optimize the index for commercial search engines. So Jason, want to talk about the metadata model?
Can everybody hear me? If I stay right here? Yeah? So one of the things that when we were starting to build out this idea, we noticed a need within the university to sort of inventory not only just scholarly data. We have a similar MSU Research Citation Index that we've built with some success and had some partnerships with our Office of Research. And so part of our thinking on this particular implementation was to build on some of those partnerships and also borrow from some of the models and the things we learned in aggregating data for scholarship. But given that, we really looked at a number of, there's no shortage of metadata standards, as all of us know. We looked in all kinds of different places. We knew that we were going to be focusing on discovery, and schema.org had just put out a type and property around data sets. So that was one of the, we knew we were going to use that as probably a core set of fields for the key value stores. We also knew that we wanted a way to describe each, should the project grow, we knew we needed a way to describe what a data catalog is. And so we turned to the DCAT catalog, which is another W3C effort to define what an entity, an actual, a full catalog is, not at the item level, but at the full broad level. because we do have a sense of this as becoming some kind of union catalog, potentially. We, in our conversations with a number of people, we were pointed to other specialized types of vocabularies like a biomedical vocabulary that had found new ways to speak to and describe data sets. And then we looked at other open web environments like the CSV on the Web Working Group, just to understand what the standards were around providing CSV files on the web. So again, we sort of oriented towards the idea of discovery. This is a post that was early February or January last year. But speaking to the release of the data set property and type and what it could do. So there's an investment at a very broad level for search engines in providing some entry points to data and how it might be found and discovered. The first prototype, and Jim's gonna, I want to get to demo because I think it's pretty cool, and I want you all to see it. But we've started on the item pages. We've started some. We're definitely modeling RDF, and we're going to embed some linked data into that. I want to talk a little bit about the structure. It's a very simple structure. You can kind of get a sense of the tables as they exist, and the other goal of this was easier implementation. We didn't want it to be too complex, so we have a pretty simple set of tables that have relationships between them. Jim's going to speak to the feeds table is really where we do a lot of the automation on this effort, and so we populate that with various external feeds that will help us do the aggregation and make records. I think affiliations is typically, whether it's a research institute or a department or a discipline, a creator is a creator, and data set is a data set. So maybe not unsurprisingly, one of the most complex data modeling pieces was the idea of how do we describe or be inclusive about a data set. We had, again, a number of standards that we could refer to build out this idea. But you can see on the screen behind me, there are lots of ways to think about what constitutes a data set, right? Whether it's a set of images, an API itself. Schema even has a data feed type or property where you can, which actually would be a way to describe an API at times. So there's a lot of complexity in this. I'm not expecting you to understand, or even really, it's really tiny print. This is more for the folks who are going to look at the slide later. I wanted to get the first run, the first pass at what the key value stores look like inside of that data set table. The one thing I would point out is that when we're doing this aggregating, and Jim will speak to it a bit more, we need a way to know if we've already archived a particular data set. If we identify a data set that is MSU related, we bring it into the system, and then we need a way to create some kind of unique hash or way to make sure that we dedupe it. We don't want duplicate data in the database. And he's come up with a really a simple but very effective way to do that, and he'll speak to that. He looks at the DOI and potentially we can hash the DOI to create a unique kind of fingerprint for it. We're also interested in, one of the things we notice when we aggregate the data, and Jim will speak to this again, and Sarah will bring it up again as we speak to the challenges. Data sets are not usually well described. Sometimes we're lucky to find a title and an author or creator. So our fields were really set up for dedupe, which I mentioned. We really wanted them to have some form of resolution, and what I mean by that is a way to keep the referring URL in place, or permanent identifier. And then we also had an eye toward how would we release this data so that other people could use it. Because as Sarah sort of mentioned, one of the things we really want to do is be able to sort of inventory the research, not only the research production, the research data production that happens at MSU. With some things that we're still sort of working through are obviously the things like finding ways to disambiguate. Researchers, this is not, I've seen a number of sessions on this during, or at least mention of this in sessions. And this is my brother's name. I feel, it's one of the things, obviously, that you have, when you start to, you have to make sure that it is the actual person that's at your institution. So along with this, Sarah alluded to, as that disambiguation happens, what we're hoping to do with the pilot is find ways, as I mentioned, usually to build out that description, those description fields, with a kind of topical fingerprint. So the working assumption is that we can get from a researcher profile, as long as we can find who that person is with some clarity and certainty, we can find some kind of topical profile related to the research they do, which we can then link to the data set and create different forms of topical metadata for. So we have, this is from a smaller project, but again, all the projects kind of feed into each other. This is just a matter of looking for ways to look at various kinds of profiles on the web and mine out keywords or topical entities. So that's what these scripts are doing. And what we can do is then push them into the topical metadata fields to provide some kind of relationships between the metadata that we're aggregating. So I'm actually going to we're going to go live demo on this, and Jim is going to take us through some of the early iterations of the project. Oh yeah.
Okay, I'm gonna attempt a live demo here of this very early prototype. It's mostly this demo is mostly the harvesting part of the product, and the disambiguation work that Jason referred to probably will come at a later time. If I can adjust this so I don't have to lean down so much. Hello. Okay. This is the entry point into the index. It's got a search box where you can search for certain types of metadata. It's got some browse points. And down at the bottom, we have just 3 of the samples that are in there. This particular database has been seeded with a handful of just sample records at this time. And if I click on this one here, I can see sort of what's in one of those records. It's not complete, but it does have some information. It's got the name of the data set, creators, date, description, DOI at the bottom here. If I take a look at the back end here, we've got this admin interface. And if I click on this view all metadata objects here, I can see that there are 6 records in that database. This is the one that we were probably looking at there. And you can see that the information that's in there, these correspond to the data model that Jason referred to earlier. If I go back to the admin page again, and this is the part here, this manage feeds, lets us kind of look at the different feeds that we're going to try to aggregate information from. We've got 3 feeds listed, but only one of them is marked as active for this demo, the Dryad feed. If I click on edit, I can edit the name of the feed and also the URL that goes to it. And I can even click this little test feed button here, and it should go out to Dryad and pull information from there. So it looks like that feed is working, which is good. So I'm going to go back now, and we're going to attempt using that feed to auto-populate some records into our database. So I'll click auto-populate here. Over here it says retrieving data from Dryad. There we go. We got some hits there. We can kind of take a peek behind the scenes here by clicking on these checkboxes over here. The first one here will show us what came from Dryad. The next one down here shows us what we were able to extract from the Dryad information. You can see like there's some normalization that goes on, like the pub date We've had to normalize it a little bit, and the DOI was extracted from the GUID. And we can also see that if I click on that red one there, the pink one, it says this is a new data set. And turn those off here for a second. And we can also click up here to actually take us to Dryad, and we can see that actual record there. We do have a couple of options here. We can say, I want to add this into our database, or I want to discard it. I'm going to go ahead and do one of each. I'm going to add the first one. I'll discard the second one. Now if we go back to this thing, view all metadata objects, we can see that whereas before we had 6 entries in there, we now have a number of other entries. And the 7th one is marked with a P, that means pending. The 8th one is a, whoops. Oh, yeah, I didn't. The 9th one has a D, that means it's been discarded, but the ones that were marked with a U, those are unprocessed records. They're in the database, but they haven't been processed yet. Let's take a look at this one. We can see this is something that was, this is one of those records that came right out of Dryad, and you can see the sort of information that we're able to get from that and put into our database. And there's some holes in the data you can see, so somebody would have to come through here and kind of fill some of that stuff in, whatever we can't extract automatically. And then there's a status at the bottom that you can set. Like if once this record is complete, we can mark it as active, and then it's then searchable, from the main index page. And we also have here the ability to export. So if I go down to one of these, the records that I know is in there, we can say I want to do either a text file, a CSV, an XML, or a JSON. I'm going to try XML here. There we go. There's an XML representation of one of the records. And if we go JSON, there's that. And we also have an API that we built for this as well, so that somebody can query that through RESTful parameters and get information out of the database that way. So that's about it for the demo.
Okay, so through making the demo, we've identified 4 big challenges, really. First, metadata sources, institutional affiliation, outlier data sets, and search engine indexing. So for metadata sources, we found that RSS feeds and APIs are unstandardized, so you saw that not all those fields were filled out, and it's hard to know what we're going to get. The Dryad feed is really good, but other APIs and RSS feeds are not as good. So one potential solution to that is to sort of piggyback on some of these services that are already doing this work, like DataMed and Synergy and OmicsDI. They're already cleaning up the metadata, so if we can pull from them, that would be a way for us to at least get some clean metadata. The second challenge Jason referred to was that data repositories often don't require institutional affiliation as a metadata field, and so the records we might not be gathering all of MSU's data sets. The records that we have wouldn't really represent a comprehensive picture of all of our data that's out there. And so we've thought of some solutions, but none of them are perfect. So we've thought of querying data repositories for the full names of our researchers, which is kind of labor intensive and then doesn't account for name disambiguation. We've thought about ORCID integration. Zenodo is a repository that uses ORCIDs, but most data repositories still don't use it. And then we've also thought about using grant numbers. Most data repositories have grant numbers in them, and we could cross-reference that against our institutional award information. And then cross-referencing data sets with underlying publications. Dryad has a script that'll do that. It reaches out to Crossref and looks at the institutional affiliation from the publication and then attaches it to the data set. But not all data sets have an affiliated publication either. Another challenge is outlier data sets, stuff like really big data sets or student data that institutional repositories have often held in the past. So we're hoping that the resources we save by building an index rather than a repository will help us subsidize some of those data sets in other places. We could pay for a 10 terabyte data set to be published. And then lastly, search engine indexing. We think that search engines like Google may not index metadata-only repositories. And so that's a challenge for us because part of our goal here is to make sure that our institutional research data is really searchable and findable. So one solution we thought of was just to provide an object in ERDI in order to improve that discovery by Google, like a downloadable text file that has metadata and a link to the data set itself. It's kind of inelegant, but it is a solution. So yeah, our final thoughts are that the prototype is in the early stages, and there are definitely challenges ahead as we move forward with the project, and we'd really like to hear feedback from this community. So please ask questions and come talk to us afterwards.
Thanks. Thanks, Sarah. I may have missed this, but you mentioned that, I guess my question is, what about the researchers who don't have a grant-specific repository specified or a discipline repository? Where are you suggesting that they put their data?
I guess it depends, but we often suggest Zenodo because it's CERN. It's run by CERN, which is a trustworthy sort of pioneer in the open access world. But yeah, that's sort of part of our challenge too, is figuring out what are the best repositories to suggest to researchers.
I found myself wondering what we can do to help researchers understand that there are some simple things they could be doing that would make their data a lot easier to find.
Yeah, that's definitely a challenge that we've seen as well. Publishing data is still really early, and so I think we're all still figuring out what the standards are in the repositories and in the metadata. So I think we just sort of have to live with messiness for now.
Maybe you said, but are you releasing this as open source?
Yeah, we have an MSU GitHub account where it is right now. And I will add a link to the slides. I tweeted out a link to the slides. So I'll add a link to the code as well.
Thanks, we'll take a look.
Yeah, we'd love for any feedback that you want to give since it is so early in the project.
Oh. We're hoping for grant, potential grant prototype.
So
should we get that, even if we don't get the grant, we will release it. It's just not there yet.
Oh, okay, I take it back. It's not yet on GitHub, but it will be. Yeah. The Research Citations app is on GitHub, and that's what the index is based on. So you can see kind of what Jim was demonstrating, some of that like automatic pulling in of the RSS feeds. The Citations app does that as well.
Hi, so thank you again for demonstrating this. I'm curious if this has helped you facilitate conversations with like high performance computing research centers, if they're interested in this, and if there is, and you may have mentioned it, some kind of mechanism you have in mind where if faculty members know where their data is or where they plan to put it, that's not in one of your feeds, if they can send you the information and you can input it.
Yeah, that's a really good idea, because that'll help us find out about data repositories, smaller ones we might not know about. We have talked with our university IT department, and they're interested in sort of a metadata index as a front end to sort of high-speed networking. So we are in conversation with them about that. We'll see. Let's see. What was there another part of your question I'm forgetting? Yeah. It's a great idea though. I'm writing all these down.
Okay, I want to thank you one more time, and then we will transition to Peter Sefton from University of Technology, Sydney, and Gavin Kennedy from Queensland Cyber Infrastructure Foundation. And, or maybe Gavin is gonna, okay.
Oh, hey, somebody left the computer for me.
Okay. Gonna get switched back, but they are going to introduce Redbox 2.
Yeah. I think it'll just come back to the main screen. Yes, let's go. Right, just loading up. Okay, good. So hi folks, I'm Gavin Kennedy from the Queensland Cyber Infrastructure Foundation, and we're doing a tag team with Peter Sefton from the University of Technology, Sydney, and talking about Redbox 2 and the provision of the collaboration that has been going on over the past year between us. So background on Redbox. Redbox is a research data management platform that assists researchers and institutions to plan, create, and publish their research data sets. It is proudly open source. It is managed and supported by QCIF. So QCIF is a not-for-profit organization that supports IT or e-research across the Queensland universities and nationally. The platform is fully customizable. It's an integration platform. It will join your platforms together, and it's interoperable, so your platforms will happily exchange information. We are progressively creating cloud models. We have a platform as a service version of Redbox 1 at the moment, and we have deployed our first software as a service version of Redbox as a very specialized platform called the RAP portal, which I'll talk a little bit about later. And it's very much community-driven across the Australian research community. So a little bit of history. It has a rich history. With ongoing support from the Australian e-research sector or cyber infrastructure sector. So originally Redbox was created on top of the Fascinator platform by USQ back in 2010 and taken up by multiple Australian institutions under the Australian National Data Service metadata stores funding program. So we got a boost in the sense that universities were funded to take this platform on board to push metadata into a national catalogue. So in 2012, QCIF took over the management of Redbox, giving it a stable, non-partisan home. And then 2015 saw our first cloud version. Last year we produced our first SaaS version with the RAP portal. And this year we are releasing Redbox 2. So just to give you an idea of the community, there are 10 Australian universities at the moment that subscribe to Redbox. So it's open source, but we have a subscription model to help cover the costs. There's a couple down there that utilize it as open source. And then we have Queensland and national agencies that support the development of Redbox as well. So Redbox 1 has been running for some time, as said. So at its core, it's a customizable research data registry, providing the forms, workflows, and system integrations to allow institutions to create and manage metadata describing their research data collections. It includes the innovative Mint platform, which provides a lookup service for researcher information and project details, as well as commonly used research classifications such as the Australian Field of Research Code. So just sort of drawing on sort of the discussion in the previous topic, we integrate it with university systems to pull in grant information, and then we can use that information to populate forms as people are describing their data collections or doing their data management planning. So it incorporates a data management planning tool, curation functions, harvesting functions, transformer functions. So it's always been a schema-less platform. It's very much a forms-driven platform, and we utilize transformers and now in Redbox 2, what we call sort of post-update hooks to be able to rendition the metadata into whatever schema that you require. In Australia, we use we render it into a schema called RIFCS, which then feeds through to Research Data Australia, which is a national catalogue. Full set of APIs and OAI PMH publisher. So Redbox 2, which we embarked upon late last year in collaboration with Pete's team, and that's seeing a technology refresh, particularly to bring it all back to a single web application. Evolution meant that it had gotten sort of messy and clunky. So we're using Sales.js as a web application framework to do that, which makes it much easier for other institutions to be able to configure forms, to be able to configure workflows. We're using a JSON LD in a Mongo database data model or metadata model, very much a modular plugin architecture. As I've said before, we have a software as a service offering now, so we can deploy one instance and make it multi-institutional, I guess is what's driving that. We're integrating with RAIDs, which I mentioned last night in the poster session, to allow institutions and researchers to track activities, research activities. Machine actionable DMPs, the workspace concept to manage resources and data sets. It's quite a list of things that we're doing with Redbox too, sorry about that. So flexible storage provisioning, data set harvesting, archiving, publishing, and a comprehensive search and discovery tool, which we will start developing next week. The goal with Redbox is to support the research data life cycle. So we're going from going sort of Western civilization left to right here, that the researcher will interact with the platform in describing their data management plans. They'll pull in IDs at that stage through the Mint system. They'll be able to pull in their collaborators, their grant information, fields of research codes. And through that DMP, they'll then be able to request access or provision the resources which will be pulled back in as workspaces, and Pete will be able to demonstrate that. This metadata is pushed through to the data collection information, so the metadata and archive component there, and then the researchers will be able to harvest both the metadata and data back into Redbox, publish it. We'll have internal search capability, as well as publishing to sort of global data catalogs, and making it accessible, findable for other researchers. Oh, okay, and so just to state that in our model, the data management or the data creation is happening outside of Redbox. So on the infrastructure that's being provisioned via Redbox, and then it's up to the researcher to harvest back what they want for publication purposes. So this isn't a demonstration. This is just snapshot of a DMP form, and by contrast, this is the RAP portal, which is a single form platform, and the purpose of it purely is for somebody to register a research activity and receive a RAID, a persistent identifier, in return. I guess a key thing to understand is that you can have multiple workflows, you can configure your own workflows, and you can have multiple states. So in the RAP portal, we have these documents can be in a draft state, and then a published state and an archive state, but you can also generate things like approver workflows as well to create approved states. And with that, I will hand over to Pete. And he'll slowly come up to the stage. Do you want me to stay?
I don't know.
I'll hang around.
Do you want to stay?
I'll hang around for that.
Should we let him stay? Okay, so that part of Redbox is kind of an established thing. It has research data management plans in them, which many people don't find that exciting, but they are probably quite an important thing, we think. And there are a few places around, at least in Australia, and I'm not too sure about international work, where people have tried to make the idea of doing a data management plan much more appealing by giving you something if you do it. So if you fill out this data management plan, this is the way you apply for storage. So that's been done. I did that at Curtin University in Western Australia. Sydney University did it. Those institutions had some mixed success with that. What they got was a lot of really bad data management plans in some cases, because people were just using the tool to get some storage. And I think some institutions have even moved away from that model. But we didn't want to give up on it, but we wanted to take an approach with maybe loftier principles, and maybe that project failed because the scope was too narrow, so let's broaden it right out. It's always a rational response. So the idea is we want to make it appealing for people to do their research data management by actually giving them something that helps them with their research. And what I like to try, and as an e-research manager, looking after IT support for research across an entire institution, I like to bring the conversation to researchers in sort of the terms of, so you want to do high integrity research, don't you, right? That's probably going to get more likely to get a yes answer than would you like a data management planning tool? Or would you like to fill out this data management plan? And high integrity and high impact are things that are drivers for people. And the integrity thing, I think, is appealing because people understand what it means. You need to be able to make sure that your research is done in a way that there's no misconduct, and you can find your data and all these things. If that doesn't work, then there's the compliance side of integrity, where we say, well, actually, I don't care if you want to do it or not. You're still going to have to do it because it says so in the policy. But so that was one principle that we wanted to appeal to people at that kind of high level. Another is sort of borrowing from the Unix philosophy and the internet philosophy of having small pieces loosely joined. So we've actually been pulling apart systems so that they're much more disaggregated than they used to be. The initial repository systems, ePrints and DSpace, were quite monolithic applications. And the same application was where you would type in the form data that described a publication or a digital object. It would look after a lot of the management workflows, and it would also do the dissemination and discovery and so on, all in one thing, right? That is means the whole thing gets quite complex, and you also have potential bottlenecks. That's something that might be happening in the management workflow might be affecting the rest of the system. Redbox, because of some dubious design decisions that happened when neither of us were after my time, before Gavin's time, that meant that there were some things which were actually blocking, like it would bring the application down because of some of the processes that were built in. We want to reduce that risk, and we want to be much more flexible, because we can come to places like this and here. We can see how this would fit into, say here, Montana, right? But you've already got some components. So we wanted to make it really, really just constructed out of pieces. And another thing that we came up with, and this came really out of the design as we talked to researchers about what they wanted, we might want to make this so you don't actually have to go to our application. You don't have to go to our forms and fill things out. So I'll give you a real example is we've been working with the microbial imaging facility at UTS. They have some big microscopes and they take pictures of microbes with their microscopes, and then they, historically they'll buy a new one, then come to us and say, oh, we've got a new thing, and it produces 10 gigabyte files, and can you store them, please? But what they wanted was for their PhD candidates, PhD students in the group, they all needed a workspace. Initially, that was a file system, and their supervisor needed to be able to have access to that workspace, and the co-supervisors. And things keep changing, right? So supervisors leave, and those relationships change. But we do actually have the institutional information about that. So what we wanted to be able to do was set loose this army of bots who would, each one would just do one thing, like make sure that the right people have access to this work area for the people in this group. So that's part of this picture that we, in many cases, things like constructing a data management plan could be quite automatic. If all the PhD students in a particular group have to do things in a particular way, we can generate it for them. They need to know it exists, because it's part of their research training, but they may not have to fill out very much at all. Okay, another key part of what we're doing is there was a phrase that came from a gentleman from Caltech in a session this morning, can't remember his name, which was continuous migration. We want to be able to move data around really freely. So one of the things we've been working on is packaging, a data packaging format, and some of the things that came up in the previous presentation we went through, looking at DCAT, looking at schema.org and so on. And we've come up with, I'm talking about this tomorrow at 12, so I won't labour this too much, but we've got a packaging format where we can take data from one system, pull it out. This is an example of a Mecha repository, which has been, so a Mecha is a lovely lightweight sort of WordPress type thing for building repositories. I've exported an entire repository from the University of Western Sydney into a zip file with this single HTML page which describes every object. And it's got a DataCite citation on the top. It's schema.org throughout, and there is a JSON LD linked data file that goes with it. There's a spec. I'd love for you to come along to this session tomorrow and give us some feedback and maybe look at implementing plugins and so on. So that's all I'll say about that. This is the diagram that kind of ties it all together. This is a kind of slightly different view from the one that Gavin presented earlier on. This was drawn by our university IT architect, and it's his rendering of the hand waving that we were doing and the whiteboard stuff that we drew. So we have a researcher right at the top, and there's the Stash 3 portal. So Stash is our name for Redbox, so it's the local brand name. And around the outside, this is the important bit. There are a whole lot of research application services that people use. So REDCap is for clinical trials data. It's a shared source, not open source, shared source application. It's really good. People can set up forms, and then nurse practitioners and people in hospitals can fill in patient data and so on. Lab Archives is a pretty good proprietary e-notebook, lab notebook system. Mecha, I mentioned, is a fantastic lightweight repository. We want to be able to provision these things for people. OME is the Amero microscopy repository, which our friends I mentioned in the microbial imaging facility are using, and we've got GitLab, which is where you do code, and a lot of projects like data science projects are actually code-centric. The code is the thing that ties things together and fetches data from data storage and so on. There's more, but these are the ones we're working on now. We're trying to create an environment where we can invite you to come along and contribute plugins. I'll show you what the plugins do in a second. And then there's also storage. We have a national storage service which is runs on OwnCloud, which is a bit like Dropbox. That's called Cloud Store. And we've got various computing services. So we've got commercial cloud and we've got a national computing service. This is just a screenshot of the application as it looked a few months ago. It keeps changing. We're in very active development for a release in the end of September. So this is a little video of adding a workspace. So you do this in your research data management plan. The person here has clicked that they want a GitLab workspace, and then they give it a name and a description. There will be templates. So if you're looking at a code project that's happening in a particular discipline, there may be a standard way of laying that out. If you're doing visualization in our visualization facility, the guys down there want the code laid out in a particular way with the right scripts in the right place. So you can template it. So what's happened now is that new workspace has been provisioned, and this is the thing in GitLab. So GitLab is more or less the same as GitHub, but it's an open source version. I might skip over this. This is our technical architecture. I'm putting it up there so you can see it. I don't know that we make much sense of it in this context. If you want to come back to the slides afterwards or come and ask us later. The important bit is there's a bit of color coding. The green box, for those who can perceive the colors, is this one. Oops. There's the biggest one there is a portal written in Sales. It's Node.js framework. That's talking to the MongoDB. There's a couple of red bits which are legacy code from the older system. We're replacing pieces a piece at a time. Those will probably go away at some point, but we don't have infinite amount of money or resources, so we're disaggregating this thing and replacing the pieces slowly. The important thing probably to note here is we've completely decoupled the discovery interface where you find things like the system we just heard about, where the index of the research data from the place where you do the data management planning and the provisioning. So, but what will happen is if you provision a workspace in one of those systems, you will be able to go back to the system and say, okay, now I would like to archive that. And it will pull it down, put it into the standard data crate package, and put it into some temporary storage, which is shown up there sort of in the middle of the diagram. From the temporary storage then, that will either be kept in an internal archive for things that aren't published, with an internal discovery system. So that's a separate index over that archived content. And if it's going outside, it gets pushed through the firewall. They're represented by bricks, to storage which is sitting outside the firewall. And there's a portal sitting on that, which will be indexing the contents of that. So you could add, I have made notes to add things that will go and harvest things from Dryad and other repositories. If we can hook that up, that'd be lovely. But that's probably all we need to say about that. That's the sort of the technical architecture. And I think Gavin wants to, okay. All right, so there are some future possibilities with this technology or this suite of disconnected, like loosely connected pieces. We can provision storage easily enough, but I think there's still a need for generic repositories where people might want to build a web-based system with APIs where they can put data of all different kinds, possibly sensor data coming from machine environmental projects or whatever. We still don't have anything really good in that space. Amica is probably the closest thing, but it doesn't have any good access controls. We are keenly aware we need to do something about preservation. So the current approach we have is that we will be, we're not going to run a repository as such, but we will be laying things out carefully using the forthcoming Oxford Common File System layout. And then that should open up the way for to run various services over the top. So the preservation people are, I believe, looking at writing software which will understand that format and be able to go and do fixity checking, format migration, those kinds of things over the top of it. We are quite keen to pitch this nationally in our country, where we might want to be able to do this sort of stuff at a national scale, so provide the planning tools and so on to everybody. The actionable service catalogue is really, there's potential with another institution in New Zealand who've been looking at this stuff from a very different perspective. They were actually sort of compiling a service catalogue intranet for their university for research services, which is a kind of different view. We came from the research planning view, but there's some potential to team up with that institution. So we actually have like a website where you go, and when you find something, like if you're looking for a microscope or an MRI machine or information about data management planning, everything's actionable. There's always something you can click which will get you what you want. And that's probably enough of that. And now Gavin would like to, I'm coming around with a bucket and you can drop money in it.
So since the conference theme is sustainability, and I'm more the business development manager for this activity. So yes, it's free open source software, but QCIF is a not-for-profit organisation and doesn't actually fund the development of Redbox itself. So I have to go out and get the money to pay for these activities. And it's not necessarily easy. It's a competitive environment. It's a commercial environment as well, with commercial players increasing their stake. I've slipped in here. There's a sandstone mentality. Sorry for anybody at home watching this on the live stream, but you get large universities that like, we can build it ourselves and we'll build something much better, and then they have all the costs of supporting that. We're a small team, but we are permanent staff. There's not a high turnover since I've been there for the past 4 years. It's been the same team. So, we do have financial sustainability processes in place. We have a support subscription model whereby our Australian institutions pay a small amount of an annual fee. We have a support ticketing service, so we will actually provide support to people, help them figure out the issues and problems. And then we run projects for the development, customization, implementation of Redbox or other research-related software. Because QCIF also runs cloud infrastructure, we also provide managed hosting, so we can run Redbox for institutions, the server instance. And as said, we're moving into a SaaS model, although that's probably a couple of years away before we figure out how to monetize that and recover costs through that. But still, in terms of sustainability, we have our community, and we ensure that we maintain communication with our community of users. We keep them on board. Redbox 2 really is community-driven development. So yeah, I'll leave it at that. Thank you.
Okay, questions? All right.
Yes, hello, thanks for your talk. Have you been working with the Research Data Alliance groups? There's some groups that are looking at actionable data management plans, common standards and data management plans, because I assume this is right up their alley. They'd be really excited to see this.
Absolutely. So the Australian National Data Service, which is a federally funded organisation, they're well in with the RDA community. So we get to watch what's happening through them and take their recommendations on board. So when I talk about machine actionable data management plans, I can't remember the name of the person involved. I think it was Sarah, somebody who sort of laid out what the Sorry? Yeah, okay, so, and laid out what an MADMP should do, so we're like, yes, does that sort of thing. I did get to talk very briefly online at the last RDA plenary, so yes, we're involved, we're following it.
And it's, with the data packaging as well, there's an RDA working group starting specifically for packaging. There was sort of some related things, and the work we're doing on that is plugged into that, and I'll be part of that group.
Any other questions? We have time for maybe one more. Oh, okay. Well, thank you. One more. Okay.
So based on the experience, not of this 2.0 version, but based on previous experience, with what kind of open repositories tools are you also connecting the red box with?
You mean like sort of archival repositories, so the end or public publication repositories? So that's still fairly open. In the community in Australia, people have made different choices about repositories. Newcastle still has Vital, which is kind of been around for a long time. The QCIF have done a CCAN implementation, the integration.
Just as a demonstration for the workshop, but just to show that it's easy enough to push things through to those types of platforms.
So that is actually unfolding. Like there's not going to be any major impediments to what we push things into, but as the current users and new users come on board, we have to discover which pieces they, which platforms they want to push to. So we don't know.
There's one more question if you've got time.
Very quickly, because we're.
You mentioned the choice of a database. Why did you choose not SQL, not Postgres? MySQL, not Postgres. Why? Can you give me a reason why?
We didn't choose MySQL. We don't actually have a relational database in this thing. It's a schemaless document store. So the team chose Mongo for reasons I don't know. I think probably prior experience with it. But we're storing things as basically collecting forms. You design what the form is, and you design crosswalks from that out to the various other metadata formats that you need. So it doesn't really need a relational database.
Okay, and with that, thanks to you both. And we will now transition. Thank you. Okay, and next up we have Neil Jeffries from University of Oxford, and he is going to talk about data to paper.
Hello, okay. Good, okay. I'm going to talk about data to paper, which was something I think I presented briefly in Dublin, and essentially it's moved on, but I'm going to go back through and give you an explanation of what it is and where it's going and where we've got to now. So the basic concept was dreamt up at a GIST Data Spring session in the bar. And the idea was to put a create data paper button basically added to a data set in a data repository. And the idea was to give somebody basically a benefit for actually putting their data into a repository and using a persistent identifiers around it, in our case basically data site DOIs and ORCIDs. The idea is that data paper really simplifies the submission process for data papers, which are publications based around data sets. So a data paper generally describes either experimental or analytical methods rather than results, and it's increasingly important for reproducibility in data peer review. if the author is an ORCID and the data set is in an ORCID/DataCite compliant repository, we guessed that there's probably enough metadata there to actually fill in most publishers' submission forms. So the idea was we would produce a cloud-based app that would essentially collect multiple repositories and multiple journal submission systems and use it to basically streamline the publication workflow. And the idea is a particular journal or a particular repository would only need to connect to data paper once and then have access to all those journals or all those repositories. So essentially, I view it coming from the commercial world as bringing some element of electronic data interchange actually to the scholarly process. So the idea is for a researcher, once they put their data into a data repository, their data is preserved. But as a result of using data to paper, by producing a data paper, they have more opportunities for citation and impact. Repositories get more data sets, they get an additional service they can provide to users, they get link referrals from the published data papers, but in a lot of cases, the data paper is actually probably the best metadata you're going to get for describing that data set. So it's a very useful thing to have linked in. Journals get a more efficient and actually, when we actually looked at it, a less disincentivizing submission workflow. We actually discovered that for researchers and journals, they realized the submission process generally was a serious disincentive to publication. They get better metadata because it's generally curated by the repositories and it's transferred machine to machine rather than relying on somebody retyping it and hopefully getting it right. They get referrals to from the repositories, and funders, by encouraging the use of data papers, actually get better impact from their funding, and they actually get more efficiency, and I'm going to go into that in a little bit of detail. So it's a very simple schematic. At the top, there's a button on your data repository that says, I'd like to publish a data paper. And that essentially sends a package to the data paper app, which sits in the cloud, and it, at minimum, contains a DataCite DOI and the submitter's ORCID. In a number of domains, they have domain-specific metadata standards, so there may be the need to package a sidecar file with additional domain-specific metadata into the publication process. The packaging allows us to do that. In the D2P app, you basically choose your journal, write your paper using a template, add your co-authors from ORCID, and agree to the publisher's terms and conditions. You don't actually fill in any metadata forms. That is then repackaged into a nude sword package, an enhanced sword package, which has got your paper in, it's got all the straightened out data. That then goes to the publisher, and then publication will update your ORCID profile if you've got it to harvest, and you'll see later on that we've done some work to actually close that publication loop within the data to paper app. Excuse me. So as I said, it was originally funded by JISC as part of the Data Spring initiative. And really that was just at a feasibility study level. It was based on some work somebody had done, Fiona, who's one of our partners now, done by RDA looking at publishing workflows for data papers. And that workflow actually now has been standardized as an EU ICT technical specification, which means if you're procuring within the EU, you're advised to actually use that workflow for publication. So effectively, we're providing an automation tool for that. So what we did is, there's a link to that if you want to actually have a look at it. We produced a straw man spec, basically fleshed out the idea and the ideas into an API and a more detailed application description. We then sent a questionnaire out to a number of repositories and publishers, well, basically spam the mailing lists. And the idea was really to confirm those requirements, to validate the assumptions we made about the sufficiency of that metadata, and to gauge interest in the proposal. And we got a lot of very positive feedback, and there's a link to the outcomes of that study in Figshare on there. So really want to go in a little bit more into detail about why data papers are actually of interest to us in this area. They're a relatively new and rapidly growing form of scholarly communication, and really they're a response to what's seen as a reproducibility crisis in a number of disciplines, where a typical regular journal article does not contain enough detail to reproduce the science. That's led to a sharp increase in the number of retractions when people discover they can't reproduce the science effectively there. And it also provides a mechanism to actually peer review data. Now data is being published, the data paper is a way of announcing that and actually initiating some sort of peer review process. There's a desire, certainly from funders, given the decreasing amount of funds that seems to be around, for an increase in research efficiency. And one of the things the data paper does allow you to do is publish negative results. So it can basically say, we tried to do this and it failed. And at the moment, due to the lack of publication of negative results, in a lot of cases, the same mistakes are made over and over again by researchers because they don't know that doesn't work, a particular approach doesn't work. On the back of that, there's the emergence of data-orientated journals, things like data science journals, scientific data, data and brief, gigascience, all of those, which means there's increasing acceptance of data papers as first-class scholarly outputs. There are a lot of external factors that make data paper publication amenable to automation. The main one being that data sets and data papers are overwhelmingly open access. So we don't have to worry about layers of access control or getting into things like that. Culturally, that is very much the case. ORCIDs have been adopted increasingly by researchers. Certainly in Oxford, we got probably 60+% adoption. And that allows us really to usefully leverage that information and that metadata within the system. And within the US, I know certainly applying for certain grants to people like the NSF is greatly simplified if you are willing to adopt an ORCID. So there are strong incentives beginning to push people in that direction. DataCite seems to have gained a lot of traction. It's not too onerous as a standard. Generally, most data repositories have a superset of that, but as a minimal standard, that's sufficient for us to work with. And we didn't discover this really until we did the analysis, just how much both publishers and authors actually hated their submission systems. That was a real eye-opener to us, and it actually gave us quite a strong incentive to carry on with this work. So these are just some illustrative figures on the growth and the volume of data papers. In 2017, counting the publishers and journals where we could get figures, there are about 7,000 new papers published, and this is from a base of basically less than 500 in 2013. So the volume of data papers and the importance of data papers in the scholarly process is growing quite significantly, and that's quite a nice growth curve from my point of view in terms of the market. We received further funding from GIST Data Spring for phases 2 and 3 to develop and document a detailed API, to validate this with some partners online, and to develop a prototype app. And where it comes into the Fedora thing is the prototype app is actually based around Hyrax and Fedora. Partners at this point, Bodleian Libraries, obviously, because I'm there, F1000 Research as a publisher, Murphy Mitchell is the company that actually did the initial RDA workflow analysis, Digital Nets did our technical development, and Microsoft Research basically provided us through Azure for Research is free hosting for the project. And the idea was to demonstrate that end-to-end workflow, and we set up an advisory panel with a good spread of people in that area. So we have Elsevier in there as a basically the big evil publisher, but basically counter F1000 Research, which is a very open access friendly publisher. So we got everybody in the market. We've got Wellcome in there as a funder, but also as a publisher, both of data and journals. CERN, because of Zenodo, University of Manchester, because they're very strong on scholarly workflows, and ORCID and JISC on board there as well. So what does it actually look like at the data repository end? It's very simple. Effectively, there's a button, and this is basically a mock-up of Oxford's repository as it was then. We've since rebranding it and relaunching it. But essentially, there's a very simple, I'd like to compose a data paper button written. It requires you to be authenticated with the repository, so we know that it's actually your data set as opposed to somebody else's. You picked it up at random. And it's written in pure JavaScript, so it's very easy to add to a web page or add to your repository in any case. You essentially push that button and the package disappears off to the data to paper app. In the app, I'm basically, this is the main screen you get dropped into, which is actually edit your data paper. At the top, there's a load of metadata that we pull from DataCite and ORCID, things like the title of the data set, the authors or contributors that we know about. If we've got contributor roles, we can pick those up, and also affiliations if we have that. Abstract and other things like that. So there's a load of metadata already in there, which you can change if you want to, but we expect the majority of people will be too lazy to actually do that. So it simplifies their life. And then on the right-hand side, essentially, there's a checklist for the publication workflow. So describe your work. First stage is, have you got all the metadata? Choose the journal you'd like to publish with. Then basically add the paper you've written, any supplemental files you want, choose the license from ones that are there, and then essentially you agree to the journal's deposit agreement and press the submit button. So there's no forms to fill in unless you really want to. In the journal selection, at the top, you can choose your journal. I've got F1000 Research up there, or a preprint repository. We're aware that the endpoint for a lot of these data paper workflows will actually be somewhere like Archival or Zenodo. There then may be subsequent resubmission of the same paper to a journal, but we support both of those as an option. If there is a template, a standardized template, and depending on the quality of the template, you can either download an unfilled template, or if it's amenable, you can actually download one where we've actually pushed the metadata that we have already into the template. So there's a little shot there of F1000 Research, and we put in the title, the authors, the abstract that we've already got from the metadata there. You then have the ability to choose a license compatible with the journal. In the case of F1000 Research, it's a CC1, so they're nice friendly guys. And you can then view the terms and conditions, basically the submission agreement for that journal. The idea is that we actually hold quite a lot more detail on the journals, and it's maintained by the owner of the journal. But the idea is we are going to help users make an informed choice as to who they publish with. So we actually collect details on things like editorial policy, but also open access status, APC charges, and that sort of thing. So you have, basically you compare journals with each other and decide who you want to publish with on the basis of possibly some useful information that we collect there and compare. And you can also see things like typical turnaround time as well, which may be of interest. One of the things we also do now is we do Scholix integration. How many of you are aware of what Scholix is? Okay, not very many, so I'll give you a quick explanation. Scholix came out of an RDA working group, and it's essentially a simple API that publishes, in its simplest form, pairs of DOIs, which are a dataset DOI and a journal article DOI that cites that particular dataset. It carries some additional information that concerns both of those DOIs, but essentially it's a data citation indexing mechanism. The API itself is very simple, and it's on Crossref and PubMed, and a number of others have implemented it. And then OpenAir, amongst others, actually provide a hub that aggregates all of this information. So essentially, by querying Scholix, I can say, what are the most recent data citing papers, dataset citing papers that have been published by this particular journal? So I then retrieve that and display that for the journals that we actually have within the system. So you can get a feel for the sorts of things they actually produce when you're actually thinking about which journal you wish to choose. Once you've downloaded the template, you've written your paper, you then have the ability to basically upload files, and before you submit, you actually have to have at least one file that's of type data to paper. The only other thing you need to do is to actually agree to the terms and conditions and check I've read and agreed to the journal's deposit agreement there before you submit. You can include supplemental files or figures or additional metadata, and will include any metadata that's been passed through as a sidecar file from the repository. RDA guidelines and general community, given that you put your data in a repository, is you shouldn't really be including data as supplemental files. It should actually be in the repository that you're sourcing it from. But we don't actually stop you doing that yet. Once you've actually submitted your data paper, then you actually have a dashboard where you can see the status of your data papers, whether it's draft, submitted, or published. And we actually use Scholix again. Essentially, once we know your data paper has been submitted, we can monitor Scolex and say, you know, when does the journal we know you submitted to, when is it actually going to release a DOI that actually points back to your data set? So we can actually close a loop there and see when the publications actually happened. At the moment, we have to poll the Scolex hubs. One of the things that hopefully will be coming out in the near future is they will actually have effectively a publish and subscribe service. So I'll be able to say, I'm interested in this data set. Let me know when something's appeared that refers to it. There's a little bit of workflow around that. If you're familiar with this, this is fairly vanilla, basically Hyrax at the moment. So you can transfer that paper to another author within the system, and they can carry on and do further work on that. The login system actually for data to paper is based around ORCID authentication. ORCID integrates with most of the national authentication federations. So generally, you actually never see the authentication. If you're authenticated with your repository in order to press the publish data paper button, you're probably already authenticated through the ORCID and through the federation into data to paper. So I didn't actually show anybody logging on. If you come back, then you'll effectively log on with your national identity federation or something similar to actually get in. We don't hold your published papers indefinitely, so although data to paper is based on a repository platform, it is not a repository. Ideally, that paper is sitting possibly in a preprint repository or in the publisher's publishing platform. One of the things we're looking at is actually to do simultaneous deposits. So essentially, when you submit it to the publisher, a preprint will also go into the designated preprint repository. That depends on the journal's terms and conditions, whether that's permissible, but that's a workflow we would like to implement. So data to paper is an interoperability service with many clients. And as you may know, there's a certain tension between libraries and certain publishers in the world. And we actually have to negotiate with them. And I can't really do that whilst working for the Bodleian Library, or it's certainly difficult. So we required a trading entity required that's independent of any particular repository, technology, or publisher. And we took our template really as the ORCID organization, because it demonstrates we can actually get libraries and publishers to work together, provided there's a neutral third party. And they're actually present on our advisory board as well. Like ORCID, we wanted to constitute it in a way that's not amenable to being taken over without stakeholder consent. And within UK law, the mechanism to do that is what's called a company limited by guarantee. So it's a not-for-profit. There is this company, Jumeirah Limited, which is the company created to operate data to paper. So I learned an awful lot about the rather painful process of spinning a company out of Oxford. So we're now looking at the place of an operational transition. So we need a critical mass of journals on board before it's worthwhile for a repository to actually implement the button. And publishers move not terribly quickly. So we're working with Ubiquity Press, for example, in the Open Journal system to add it to all their data journals. That'll probably go fairly quickly. F1000's platform and consequently Welcome's platform already accepts stored packages, so that life was easy there. One of the things we're looking at is also working with Overleaf. They provide an authoring environment, so rather than just downloading a template, we could drop you straight into Overleaf with their LaTeX template, and they can then handle basically the downstream submission for us. We can just give them some metadata. So in the short term, we're really working with some key journals like Data in Brief and Data Science, but we're also looking at well-defined scholarly communities which have a small number of repositories and journals that they use frequently for the majority of their activity. And it means we can implement for that relatively small community or well-defined community and demonstrate the benefits and get a controlled environment for actually benchmarking and optimization of that. So two of those are the Deep Carbon Observatory and ESIP, the Earth Science Information Platform, so the groups there. As I said, publishers also include preprint repositories, and actually in circular terms, some such as Zenodo who are working with, they could be both the data repository and the recipient of the preprint afterwards. So they will actually sit at both ends of the particular workflow. So currently, we're funded by a combination of bodies, so JISC, the Sloan Foundation, we have a little bit of open money from OpenAir to the Scolix administration, and Microsoft Research are supporting us as well. Longer term, we can't continue to be grant dependent, so we're looking at a transition. And we're looking at an organizational membership model, much like ORCID, but we reckon it'll be a lot cheaper because actually the app itself is relatively straightforward to maintain and it doesn't grow because we're not a repository, we're primarily a workflow engine. We're looking at membership model also because effectively we don't want to charge the academics per publication, and we're looking at a 5-year sort of timescale to achieve that transition. What we will do, obviously, still is look for grants and other things like that if we're extending those services. So really I wanted to say is also the underlying proposition is really about a workflow engine that connects different systems and actors and leverages and recycles metadata. And there's no reason why that doesn't apply to a number of other workflows. So preprint to publication from archival or something like that is an obvious workflow. Integration to other things besides Overleaf, so things like Google Docs might make sense. And there's also some broader things such as OpenAir's Open Research Graph, where they're looking to actually pull in a much broader range of resources and make that into a linked data graph. So we may be able to pull in a much broader range of information and actually contextualize data and the publications much better and look around that sort of thing. And that's it. Thank you very much. Contact me if you want a demo or something like that. And any questions?
Okay. Questions?
Do you know what the current data paper adoption rate is by various data repositories?
What do you mean by that?
How many of the prominent data repositories have actually that create data paper button listed there? So when you deposit,
as I said, we haven't put that on yet because
it's
we're
not?
still building the critical mass of repositories to do that.
Okay, I misunderstood.
So what we're doing is, in running up to the end of the year, we're looking at these targeted communities. So DCO is effectively a portal onto about half a dozen repositories. Because we only need the data site DOI, we can actually put the button on the portal, not on the individual repositories. We know that community, and we know they publish in probably half a dozen different journals. So that will give us basically a closed pilot community to work in. At the same time, we can pursue the slower process of integrating some of the large publishers. As I said, people like F1000 and Wellcome, we can give them a sword package and it goes straight into their workflow. A lot of the big publishers, when you actually talk to them about mechanics, although they've got a web submission form, behind the scenes it's actually still humans. So we actually email them a zip package with the paper and the metadata in, and the humans who basically key the output of their web front end just key that stuff in as well. So it's been kind of illuminating to us what the actual real processes in publication really are. And these things, that's why these things are actually going to take a lot longer. We thought, oh, we'll just push it into their web front end and it's all data driven, but reality isn't quite like that.
Is there another question? Yes.
Hi, thank you. I got a bit lost here and there, but I was interested in how you were linking up the DOIs between the publication and the metadata.
Right, that's not something we do. That's effectively the Scolix service. So that essentially any publisher or aggregator can implement a Scolix endpoint where they basically make available the DOI, the article DOI, and the cited dataset DOI. So it's an API that exposes that information. Then various projects, so Crossref does that, PubMed does that, and a few others do that. Then things like groups like OpenAir run a hub, which basically queries all of those, aggregates it all into an index. We can then query the hub and say, for this dataset DOI, do you have anything? What they're looking to do is, in the future, is go to a point where we can actually say, we're interested in this DOI, let us know when something's happened, so we can go from polling to actually being notified. So yes, we're looking quite closely at what OpenAir is doing and what Scolix is doing in terms of that initiative. But that's somebody else's product that effectively closes a loop in the system, and we weren't going to re-engineer that if somebody's already done it. But that came out of an RDA working group, and I think it's actually a very successful and interesting thing to look at.
So a simulated system is the phenomena that is being simulated. So in this case, it would be the hurricane, the storm. These simulations need a model that represent the characteristics of the simulated system. And this is a computational model. In this case, sometimes computational models are created by the researchers, and sometimes they are created by a community, and they are software pieces. In this case, for the hurricane, you have AdCirc, Search Guidance System, is one of these community-built computational models. Then, in order to feed the model, you need input, which is normally observational data. For example, the input to this model would be wind advisories that are released by NOAA. They measure the wind, and that will be an input to the model that simulates the storm. And as an output, you have maximum water levels forecasts. So this is what you see when you watch the TV and the news. This is you have a model, it's a computational model. You put input from observational data, from real or synthetic data, and then you get your forecasts, your predictions. And when you run a simulation may entail iterative runs. So you need many runs in order to determine these forecasts. So, that's how I learned what these researchers do. And so, to me, then it is important to understand what a simulation research data set is. So I understand the research, then I try to understand what the data is. And a research project, a simulation research project, may entail different simulations about the same phenomena. You're studying a same phenomena, but from different perspectives. So maybe your models differs, no? So you build or you put certain different inputs. So in the same model, you will get different outputs. So simulation projects can be very convoluted and iterative. Each simulation project may have a structure, of course, that is given by this, model, inputs and outputs, and then you have relationships and iterations between those. The data sizes and numbers are variable and could be of the terabyte level. You can have simulation running on your laptop, and many has, but you have simulations running in parallel supercomputers that output terabytes of data. And there's very little experience in the community describing and publishing simulation data. So the researchers really have very little understanding of what data should be preserved, how much data should be preserved, what is usable, what is not usable or reusable. And so this is the panorama. And what you see there is a data model built after interviewing different researchers about their simulation and trying to abstract the information. And so the blue bubbles are these main entities or categories, and metadata around them are the characteristics, the parameters, and the descriptive information that we will need to understand what that simulation entailed. So what is Design Safe CI? So this is cyber infrastructure for lifecycle management, analysis, and publication of natural hazards engineering data. The vision is that researchers may complete their entire research process in this platform. They conduct the simulation in the platform, they curate the data in the platform, they publish the data in the platform, they archive the data there, and then they reuse it also from there. So that's the vision. These are huge data sets And so keeping everything in the platform, keeping everything in the supercomputers is something that is more efficient. That's that's the vision for the cyber infrastructure, which, by the way, is funded by the National Science Foundation, and it's a 5-year project. My role there was to design the interactive curation and publication pipelines for not only simulations, simulations was just one part, but also for experiments, hybrid simulations, and field reconnaissance data sets. But we will focus on simulations because it is a very unique type of data set, and there's very little knowledge about how and what to publish. So to design these interactive curation and publication pipelines, we got users involved in the project, in the design process. There's a data requirements team, a simulation requirements team that meets every 2 weeks and from which we gather use cases and information to build these data models and to build the interactive curation interfaces. We get their feedback and we get their input. The authors of this presentation that were presented reflect the multiple disciplines involved. So I am the data curator, there's a simulation researcher, a professor that teaches engineering, natural hazards engineering, there's a web developer, computer scientist, etc. So what is design safe in contrast to institutional repositories? And I wanted to highlight that because that's what you have been talking about all these days. And there are certain differences and certain similarities. So design safe would be a hybrid between a content management system or data management system, an institutional repository, and a science gateway, which is the way in which supercomputing centers call these portals through which researchers send data to the supercomputers for calculations and computation. So in this hybrid, so to speak, in this cyber infrastructure, data transitions from active research to curation to publication to archives and to reuse. So everything happens or could happen there. So because data transitions, we don't have just a data publication and repository static phase. We have different spaces where different research stages, these stages that we talked about, take place. So in this case, we have a workspace, we have a data depot. Within the data depot, there's also a field reconnaissance portal, but I avoided so not to confuse everybody. Within the data depot, you have a curation pipeline, you have a publication pipeline, and you have an archival instance. So within transitions, as data is being brought into or generated within the system in supercomputers, you have metadata and data that are forming, no? They are evolving, they are forming as this data is being created and managed there. And just here, I want to show on the top, you have the workspace that is full of different applications that users from their working directories, from my data, they can pull into and use these different applications and spin Jupyter notebooks, MATLABs, but they also send data to supercomputers for where the models, these AdCirc models or OpenFOAM simulation applications are installed and they're run, and then the output comes back to these workspaces that where they manage their data. So, what did we do, or how do we start these interactive curation pipelines design? So we first designed a data model between me and the researchers. We mapped that data model to interactive curation and publication functions, and we involved the designer, a curator, and the developer. Then we evaluate the model fitness to real data through interface design mockups, and that involves the designer, the researcher, and the curator, and we get into a feedback loop. And then at the end, we evaluate users' adoption of curation pipelines and of resulting data representations, and we do that with usability consultants curators, designers, and users again. So this is the stages, and we have completed the first 3, and we are going through the 4th. So that's what I wanted to tell you, what the steps are and the stages of this process are. So first, the simulation data model. So that requires the involvement of the simulation requirements team members. I gather simulation workflows from geotechnical, structural, wind, storm, search simulation researchers, and devised from there a general simulation data model and individual vocabularies that define the differences between these different domains, you would say, or subdomains. So my data organizational categories, this data model is very simple. You have your project, you have your simulation model that you need to describe, inputs, outputs, and you can do analysis out of these outputs. And for each of these categories or entities, organizational entities, you have metadata. And here I put just the minimum metadata so that you can see. And each of these terms is going to be described in a dictionary, in a data dictionary. So that was the job that we completed. So based on the workflow and the discussions with the researchers, we get a data model, which is basically a way to organize data and the metadata that needs to describe these buckets of data. This comes a lot from my my records management past and expertise. So what happens with users being designers, meaning these researchers that we work with? They, of course, felt ownership of the data model. They were very comfortable drawing their workflows and explaining what their steps were and talking to us about, yes, the data model is, yes, it's true, it's an input, it's an output, put the model in the middle, put the output, in this relation. There could be many models in a simulation, in a simulation project, or there could be many inputs, different inputs and different outputs, and the same model, describing their research. They were very comfortable. But there was a lot of difficulty to comprehend curation functions. They didn't know what curation meant. And worse yet, how to design interactive curation. What was that? What is that? So, and also for them, in terms of curation, the boundaries between active and public data are very blurry. They don't quite understand this issue of, I'm working with my data, then all of a sudden my data becomes static, and it's in a repository, and somebody will reuse it, and I don't know for what purpose, and I don't know what to do with that. So after going through other data models releases and confronting that difficulty, we realized that doing mockups and data fitting tests proved efficient tools to involve the researchers. So we went from this drawing to mockups. These are to your, I guess, to your right. You have different mockups. This is like an interface design. And when we started showing what their data would look like, they then started to decide, no, this shouldn't go here, this shouldn't go there, the interactivity should be this way. I don't think that the metadata, is really related to the model. Now that I see it, it is related to the project, or maybe, they started to interact with you and understand the relationship between what they see, their data, and the description of that data. And what does categorization and what does curation mean? So just quickly to walk you through, you have data coming from the research workbench. You also have data coming from outside because they maybe performed simulation outside of the platform. We have to take into consideration that. And then they uploaded it to my data. We have to have large data transfer methods. So we have Globus Online, UTBox, which is very limited. Any Dropbox, UTBox is very limited, or rsync, command line tool. So we have to have a little bit of everything. And then the user gets to their dashboard, and they can describe their project first, and then they start curation. And what does curation means? And that's the other interface. So it means that you will have these big categories. You describe your model and you add information about your model. It could be just AdCirc software, and we have controlled vocabularies. We have some terms that the users gave us for their specific simulation types. And for each iteration, users can just group certain files, select certain files, and categorize them through the interface. So they group things interactively. And then, of course, over the course of the time that they're curating, they might delete certain categories. They might decide that not all those files really belong to that input or to that output. They can, curate and configure these back and forth, back and forth. And so you can imagine that metadata is being written, but it's also being deleted, and it's also written again or redone, etc. So basically, so you pull the data, you categorize the data, you then relate the data, because our data model focuses a lot on provenance, so we really want to have data that belongs to one input related to that input, and data that belongs to an output related to a specific output. Maybe you did another iteration and you have another set of outputs. Maybe you change something, you change one input, and you have another set of outputs. So we have to relate that through selections. And the user, at the same time that they are doing this, they are looking at the tree that they are forming, at the structure that they are forming. And then there's another view, a browsing view, that allows them to see all the data as it corresponds to each of these big categories. So they go back and forth, and then I didn't go further into the publication pipeline, because then once you have all of your data categorized, so to speak, and described, you can go to the publication. The publication is very similar to any publication pipeline, where you just edit metadata, you check that your files are what you want them to be published, you can uncheck certain files, etc. And the files that you do not publish, they don't get published, but you still have all of these files in your workbench. You still can keep working. So these blurry boundaries and these data management / curation / publication stages have to be well defined on the interface, so that the user doesn't get lost in all of these situation. So what is the architecture that supports these? And up to now, you have seen only mockups, and the mockups were useful so that the users were saying no. For example, they were saying, don't put, the model, the input should be feeding into a model. No, put the model up and then inputs and outputs. I mean, they were, working with us on what representation best fitted their idea of what a simulation is. So the architecture. The architecture, as you see, I just speak about the architecture of the curation and publication pipeline, not of the entire design safe, because it would be too much. But, sorry. So you have Django that links all the front end with each of the external services. And we have storage services. We have high-performance storage services. There's a Fedora instance that's for data that is published, and then there's the rest of the data that is evolving is stored in another instance of that same Corral high-performance storage facility that has geographical replication, and it also has a tape archive for dark archive. And then, of course, we communicate with other services like ECID to provide DOIs, and everything is brought to you by the Agave API, which communicates with these different services, and also within the design safe, it takes care of all the move, transfer data, etc. So at this point, Fedora, the repository that we all know, only works in a way as a dark archive, but also to structure the metadata. So the metadata that is being formed, that the user inputs, and then at a certain point, he or she decides, this is what I want to publish, that metadata goes to Fedora, and we will see how, and the data goes to Fedora. But all the data really stays put also on the Corral non-Fedora repository so that users can keep working on it if they want, if they need it. And they can even publish, let's say, a new set of simulation within that same simulation project later. So, from evolving to structure metadata, we really use Fedora's capability to structure the metadata. The representation, as I said, focuses on the project's provenance and understandability. But we, in the future, need to search, of course, people need to search across projects. So there's a mapping that goes from Dublin Core and Prov. It's pushed to Fedora. And Fedora enables metadata useful to do searches within and across projects. For example, if we want all the simulation outputs related to the AdCirc model across many projects, that is what the structure metadata is allowing that. Instead, the metadata that is the messy metadata that is not that is evolving would not allow us to get to that precision. Here, I just was showing you how we map our data model metadata to Dublin Core and to Prov, and then there's an example of how you would here, how you would the elements that correspond, I'm sorry, the descriptions that corresponds to those elements. So I want just to show you the publications, how they look now. And here you have one of the, I want to show you these publications. So there's this publication, this is how it looks like. You have a free field, what? I'm sorry, so what happened? How do I change the screen so that it shows? Or maybe I just follow the, what? Oh.
Minimize it a little bit.
Yes. I know.
Oh, no, too much.
Yeah.
And then drag it.
Not the other way. Oh, I'm sorry. Here. But I don't see it. That's odd. Let's see. I cannot maneuver this from here. Hold what? Yeah. Okay. Perfect. Thank you. So this would be your publication. So here you have your research workbench, and you can go from the data depot to your workspace, etc. And here, this is a published simulation. It has the project metadata that you have added. It has a citation and a DOI. And then this particular simulation has, in fact, there are two simulations within the same project. So this is one. The first simulation is the same model, but the inputs are different. So you have effective stress dependent constitutive model, etc. But it's the same project, and you have your model, the description of the model. Then you have the simulation input. These are the simulation outputs for this particular iteration, and then you have the other iteration, so you can publish the metadata for each one. And then you have analysis and reports for each of these two. And there are certain features that make this, collapse or not, so that you can focus on whatever you are interested in being focused on. And then we have, in order for you to see the entire project or what it is, we have a representation. So this focuses, as I say, on understandability of that project. I'm sorry. Okay. And now I go to the end. So, the conclusion. So we suggest that this model is extensible to simulations in general. The model that we did for natural hazards engineer, but it could be adjusted to simulations in general with a different vocabulary that will suit the different needs. About the flexible data model, some users would like more structure. Most are happy with the results. If you see two simulations, they will have the same categories, but they will have different structures. And so many users are happy because they say, well, this is the way I structure my project, and this is fine. But others would like just to have everything like the same and not so many possibilities to categorize data in different ways. In terms of the researchers' PI involvement, the process allows users to reflect on their data structure and representation. Curation needs not to be a burden, but something that is kind of ongoing with their project. And of course, there's a balance between the research interest and the publication goals. So we are still struggling with that as we stream the interface. But we have gotten the interest of the PIs, which is what we wanted. We have them thinking about what they have to represent. We observe and obtain feedback from new users. Already we have relocated some of the entities, for example, reports and analysis elements in the model, and we expect to improve metadata as we move forward, because we were giving certain terms and people want to add more terms, or they think that some terms are redundant or that they don't represent what they think. Interactive curation, we really now have to work towards automating, improving the automation, facilitate creation of groupings via queries, use of data model ontologies with machine learning to stop with this idea of having to check and select and group data sets manually. There's also a divide between active and public data, between the cyber infrastructure and the IR project, so to speak. And we need to work on dynamic exchange between active and published data sets using Fedora across the life cycle, as opposed to just using it at the end for data publication. So Fedora needs to be our ongoing platform, as opposed to be just the dark archive and structure metadata facilitator. And that's it for now. I mean, that's it. Oh, I'm sorry, 5:31.
Okay, actually I was going to say we are out of time, but if you want to ask Maria questions, I'm sure she would be happy to answer them. We had 4 very interesting presentations about works in progress, so let's thank all of the presenters.